Today, it is my privilege to cordially welcome the entire MOES fraternity to the 17th Foundation Day celebrations of the Ministry of Earth Sciences. We have with us our Secretary, Ministry of Earth Sciences, Dr. M. Ravichandran, respected former secretaries, former senior officials of MOES with us today. We also have Dr. Shailesh Naik sir in person with us today. We're also graced by the presence of directors of all our institutes, distinguished scientists, AS&FA, Sri Vishwajit Sahayji, Joint Secretary, Sri Senthil Pandyanji, research scholars and colleagues. A very welcome to all of you. To begin the proceedings of the day, please welcome on stage Secretary, Ministry of Earth Sciences, Dr. M. Ravichandran, to the dais for delivering his Foundation Day message.
Very good morning. Dr. Shailesh Naik, former Secretary, Ministry of Earth Sciences, and my dear colleagues from Ministry of Earth Sciences from here as well as online. First of all, let me thank you for coming, all of you coming here, and I greet you all on this 17th Foundation Day of Ministry of Earth Sciences. As you all know that, I think 17 years of journey of Ministry of Earth Sciences has contributed to the national development in various aspects in terms of science and services to the nation. Especially when you talk about weather forecasting, we have improved significantly, much more than maybe in the few years back, significantly contributed. And the ocean sciences as well as the solid earth and the polar science, all the fields we have significantly contributed. I thank you all for your contributions, and I look forward to continue your contribution for the growth journey of the Ministry of Earth Sciences. I have 5 things to always to mention, which is always pondering me to work more. Number 1 is, of course, there are many, but of course, the 5 things which I am looking forward in 1 or 2 years, what we need to contribute by the ministry to the nation. Number 1, in the atmospheric science, we need to improve the forecast, weather forecast in the various time scales. For that, we need to have more and more observations in terms of in situ as well as a radar, as well as remote sensing, or many other things. I think in 1 or 2 years, maybe in 1 or 2 years, we need to establish entire country in the footprint of radar. That is number 1. And from that observation, we need to assimilate and we need to improve the forecast significantly, quantum. So now we need to find out what is the present skill score and how to improve the skill score much better. That is one of the important things which we need to worry about and contribute. And secondly, in the ocean science also, we are very soon, we will be coming out with the blue economy. Under that blue economy, what we can contribute with all our ministries, especially all the 5 institutes in the ocean. So all the people, how we can chip in and how we can contribute and how to make a country proud to have a blue economy contribution. For that, we need to work together in various aspects, either it is energy or water or food or the transportation or many other things. Even many things, many people may not be knowing, only we have to feed to other people, shipping ministries and other things we need to contribute in terms of optimum ship routing or many other things which they are not aware, so that the country's economy will grow. So blue economy, under that we have already taken up the deep ocean mission. So the deep ocean is the blue eye boy of the ministry now. So we need to work towards that to fulfilling what we have set for the objective. And especially I'm very eager to know about the of course, no means we need to deliver the Samudrayan mission, so in a timely manner. And the third part is, of course, is polar science. And the polar science is, yes, the poles are very important, but we are not still bringing the importance of poles in our day-to-day life in terms of even weather forecast or climate change and other things. I strongly believe that there is a strong teleconnection between the poles and the tropics, which we need to understand further and incorporate in our various forecasting systems. So that is more important, which we need to look at it. And the fourth one is a solid earth. I think everybody is thinking that we are warning very good warnings in the earthquake once it has happened. So maybe within the shortest time, but it is always good to have some precursor. So maybe we will be able to have few seconds before whether we will be able to have any signal or anything to inform. So if you do it, I think it is a great achievement. With this, all four things we need to work together, and also we need to build our capacity in the earth system science, especially youngsters, to grow more and more in this area to understand, to make a better services to the nation. I think with this, I once again wish you all happy Foundation Day, not only from here and as well as online. And I will talk about much more in the afternoon about our ministries, what we have done and what we need to do. Thank you very much. Thank you once again.
Thank you, sir. Now we have a series of popular lectures by our senior scientists, directors of our institutes. Dr. G.A. Ramdas, Director, National Institute of Ocean Technology, Chennai, is an expert in the field of deep sea technology, deep sea mining, underwater acoustics, and marine instruments. Currently, he is coordinating the development of the Indian manned scientific submersible, the Matsya 6000, which is intended for carrying scientists to 6,000-meter depth in the ocean. I take this opportunity to welcome Dr. Ramdas to deliver his talk on the Deep Ocean Mission, which is a multi-institutional mission mode project of MOES.
Secretary Dr. M. Ravichandran, former Secretary Dr. Sailesh Nayak, colleagues, friends, ladies and gentlemen, a very good morning. And warmest greetings on the Foundation Day of Ministry of Earth Science from NIOT. Now I have the unenviable task of showing the torch to the sun. Whatever I'm going to talk, I think you already know about it, and probably some of you know better than I do. But it's an occasion for me to share what we are doing on Deep Ocean Mission. Yeah. As you can see, India has a large exclusive economic zone. If you add extended exclusive economic zone and the areas given to us by the United Nations under the International Seabed Authority, we can say that our land sea area is almost as big as the land area. So we have such a vast sea area, which is a treasure trove of many living and non-living resources. And I will not tell about the journey of Department of Ocean Development, which was established in 1981 and which became a Ministry of Earth Science right now. As you know, actually, the Deep Ocean Mission of the Government of India, this was announced by the Honorable Prime Minister of India, Shri Narendra Modi ji, in September 2021. And it found mention in his speeches from the Red Fort and the Parliament. And as you know, actually, we always say conquering inner space, that is ocean, is difficult than conquering the outer space, because there the pressure difference is only 1 bar. Even electronics can work in vacuum too. But in ocean at 6,000 meters water depth, if you see, the pressure difference is 600 bar. So it's a big challenge to overcome. Probably that is why you can control Mars, a rover working on Mars sitting here. And if you have a decent telescope, you can see Saturn rings. But if you drop something below 25 meters water depth, you cannot see it. And if you put an instrument beyond 25 meters, you cannot control it, because electromagnetic waves don't travel in the oceans. So that's why ocean is, though it's more important to the humankind, and 60% of the world population lives in coastal areas, but yet we know more about the surface of Moon and Mars. So these are the difficulties in conquering the inner space, that is oceans. One is it's a dynamic medium. hydrostatic pressure, as you might have seen what happened to the Titan submersible recently, and density and salinity variations, temperature variations, corrosion, and finally absorption of electromagnetic radiation. Seeing the importance of deep ocean, Government of India has launched a deep ocean mission with a budget of around 4,800 crores spanning 5 years. It has actually in 2 phases. First is 3 years and second is in 2 years. And it has 6 verticals. It almost actually, if you can see, it's spanning from the technology development, observations, and extraction of living resources, non-living resources, and finally bringing all the researchers working in the field of ocean science and technologies. It covers almost every aspect of ocean science and technology. So the vertical one is about development of technologies for deep sea mining, underwater vehicles, and underwater robotics. As you know, these are some minerals occur in the exclusive economic zone, but many of the minerals, especially non-living resources, they occur in the high seas, which are actually beyond our national boundaries. So it is beyond our EEZ. It's called common heritage of the mankind. So here some of the minerals of our interests are listed. First one is gas hydrates. That is, of course, in the EEZ of India, beyond 1,000 meters water depth and below 100 meters below the seafloor. These gas hydrates, which are actually reserves of methane gas, they exist. And beyond that one, polymetallic nodules, which are like potatoes found on the seafloor, which are rich in cobalt, nickel, manganese, and iron. They are at the depth of around 5,500 meters in the Central Indian Ocean. And cobalt crust occurs at around 3,000 meters. And polymetallic sulfides, they occur at around 3,000 meters water depth. And we have got an area given to us by United Nations at 26 degrees south. So these are, this is to say that our interest spans up to 5,000 meters water depth. So if we have some technology which can work at 6,000 meters, it covers Indian seas as well as the Indian Ocean. So objective of this vertical one is to develop technologies, indigenous sustainable technologies for exploring the living and non-living resources. The deliverables are developing one integrated mining system which can go at around 5,500 meters water depth, collect the minerals from there, and pump them to the mothership, which is actually at around 5,500 meters height from the sea bottom. And second is to deliver a manned submersible, which can take 3 human beings, we call them aquanauts, to 6 kilometers water depth for a period of around 12 to 16 hours in normal circumstances. And if there is an emergency, it is for 96 hours. It is completely different from the ordinary submarine, which can go up to a maximum depth of 300, 400 meters, and which can take a large number of human beings for a long time, actually. But this scientific submersible is meant for exploration. Coming back to mining system, we have got an area of around 150,000 square kilometers in Indian Ocean. After survey, we have handed over 75,000 square kilometers to, again, International Seabed Authority, and NIO Goa, NIOT, and IIMT Bhubaneswar, and many other organizations are working in this one. NIOT is involved in developing technology for mining. So we have adopted something called flexible riser technique, where there is a mothership and we lower a mining machine to the sea bottom. It moves on the bottom, it collects the minerals and pumps them using a high pressure pump, positive displacement pump, through a riser to the top of the ship. It is easier said than done because all these technologies should work at that depths and that temperatures. And we have to supply all the power from the top. So we started with the 500 meters submersible, that is actually mining machine. Long back, we were working in project mode at the time. You may wonder why we have done it for 500 meters when there are no nodules. We put artificial nodules there and we collected them and pumped them to the mothership. And I'm happy to inform you that India was the first country to do so at 500 meters water depth. We learned the technology, but 6,000 meters is totally a different ball game. The soil is very soft there. Whatever you keep there, actually it sinks. The shear strength is around 1.5 kilopascals. So, but you have to test the soil strength and you have to make your machine which can land there, which can move forward and which can work and collect the minerals there. So we made one in situ soil tester. We sent it there and we estimated the soil strength. And we made remotely operated vehicle to investigate the water column. With these inputs, we started making mining machine for 6,000 meters. And we have made this mining machine. Now it is adopted as a mission mode project under this deep ocean mission. In the first stage, we made a mining machine. We operated it successfully at 5,270 meters, which is a record in the world. It is able to collect the nodules, which are like potatoes put on the seabed. But to do these things, we need to have some kind of environmental impact assessment, and we have to submit an environmental impact statement to the International Seabed Authority. For that, we have to put the equipment there. This also we have achieved. So the first stage has been completed successfully. Second stage is demonstration of pumping capability to the mothership. We have to crush the nodules, make a slurry out of it with the seawater, and pump it to the top. The friction that actually generates in the riser is so high, you need very high power pressure pump. And that pump alone weighs actually some tons, 5 to 6 tons, and it consumes more than 1 megawatt power. That you have to send it from the top. So you have to have an umbilical cable. If you wind the umbilical cable, that will be taller than the ship. Okay, so there are many challenges. We are overcoming it. First stage has been crossed. Second stage will be demonstrating by this year end. Third stage of integrating these three, it's a very difficult thing. That we'll be doing it by end of 2025. And we are on the schedule for that one. This is the world-class remotely operated vehicle we have made, actually developed in NIOT, and we have used it up to 5,000 meters water depth. And we are using this vehicle for supporting all our other activities. But when we are operating, we saw one thing. If you have a cable, the range is very much limited. If you don't have the cable, if it is an autonomous underwater vehicle, you don't know what it is doing unless it comes back. If at all it comes back, you cannot get the data and you cannot analyze. You cannot give any control actually for that one. Not like space vehicles where you can sit and control, which is there on the Chandrayaan or Mangalyaan. So the best compromise is to put a human being in the loop, at least till we get all the information we require about the ocean. Okay, for ocean exploration, man is required. It is unfair to compare Gaganyaan and Samudrayaan, because Gaganyaan, it may be actually an option. Samudrayaan, it's not an option. At present, human beings should be there because electromagnetic waves don't carry. You don't have GPS, you don't have radar, you don't have lights, and temperature is low. So, means you have to use sound. Sound is 2 lakh times slower, and the information carrying capacity is very small. It doesn't go in straight lines. It's a messy affair. So you have to have a man till we get all the information we require. So we always say, if all the disadvantages are removed and if the advantages are combined between AUV and ROV, then we have a manned submersible. So it is not a fancy equipment, but it is required for many deep water explorations as well as the engineering interventions. It's a vehicle. You can put any sensor, any tool for this one, which reading this one. As you can see, the first manned submersible, scientific manned submersible was celebrated, Alvin, which is operated by Woods Hole Oceanographic Institute. They used it for actually recovering a lost hydrogen bomb in US. And the second one was actually used by Japan. Their manned submersible Shinkai was used for finding out the hydrothermal vent. That was the first time they saw hydrothermal vent at 3,000 meters water depth. So this is a very useful tool for the humankind. So what are the ingredients of this one? We used to call it manned submersible, but I was told that I should call it human submersible because we have to really cater to gender balance as well. So we need 3 human beings who are willing to go down to 6,000 meters water depth. They don't need to wear any suit. They don't need to face any extra G's or radiation or weightlessness, nothing actually. They need the mental toughness and knowledge to really operate the manned submersible. They have to be in an enclosure, like it's called short sleeve environment. They normally breathe without any apparatus, but we have to release the oxygen and remove carbon dioxide. And they have to be in an environment which can withstand 600 bar pressure. What happened in Titan recently? There are some things. We have to follow the design properly, and we should select the right material, and it should be certified from the beginning. Okay, every design aspect should be certified. every material should be certified, and finally it should be tested. All these things not happened in this Titan submersible, and we know the result. That's why we are starting from the scratch actually. We have selected a titanium alloy human sphere of 2.1 meter diameter, which can withstand 6,000 meters water depth. And we need to give oxygen and remove CO2, life support system it's called. And it needs an exostructure, and it needs a ballast and trim for going down and coming back and adjusting its attitude. And we need propellers to go around in all 3 or 6 directions. And finally, you need a platform to launch and recover. There is no cable, it's autonomous, but it has to be launched on the water and it has to be recovered safely. So this is with these applications and with these constraints, we arrived at some specifications, and you can see this how the ship systems and underwater ships and systems look like. These are the critical technologies. We have been operating unmanned vehicles, but operating manned vehicle is completely different. And this technology is not readily available in the market to procure. Even if it is there, it's a dual-use technology. Nobody readily shares this technology with you. So vehicle design, personal sphere, viewports, which can withstand that pressure, life support systems, power budget, and emergency rescue system, how to recover people from 6,000 meters water depth if anything happens. So these are the specifications. We arrived at 6,000 meters water depth because all the locations of interest are at less than 5,500 meters water depth. So this is the depth rating. And it can carry only 3 human beings. That's a standard. We followed that one. And it can take a payload of around 200 kg. So you can fit multi-beam sonar, side scan sonar, or samplers, robotic arms, and even some kind of lab to deep tools. This actually, you name anything that can be fitted here, if provided it can take that pressure. And it has state-of-the-art navigation systems for accurate positioning and to know where you are going exactly. Though this is how it looks like. There are so many subsystems. Each subsystem has to be designed, and it has to be approved by DNVGL, Norway. And each subsystem has to be, even the manufacturer should get a certificate of manufacturer. And after that, it has to be tested and it has to be integrated. All these stages, certification agency has to pass it. It's a torturous process, but it helps human being to come back safely after the exploration. So we started with one shape. It went into many iterations with the help of IIT Madras, Indian Navy, DRDO, ISRO, and academia. We are taking help from all institutions. We are working together. And so with all this help, actually, with all the iterations, this is the final configuration we have arrived at. And how does it go down? This submersible is made to float. Sinking is an effort. So it actually, though it weighs 26 tons in air, it actually floats in water. You take 3,000 liters of water inside, it becomes 300 kg heavy, it goes down. When you go down to the depth you require, you drop some weights, lead weights or steel weights, and become neutral, then move around. You may ask, you have propellers? Yes, we have propellers, but they are used for going around, not for going down and coming up. That's how we preserve batteries. We have triple redundancy in power, in communication. Everywhere there are 3 times redundancy. If something happens, you can intervene even from the top. So this is the CONOPS, it is called, concept of operations. So there is a small movie actually.
This is Matsya 6000, a deep water manned submersible to take 3 human personnel to the huddle depths of ocean. This manned submersible is being developed by National Institute of Ocean Technology, NIOT, under the Deep Ocean Mission of Ministry of Earth Sciences, Government of India. Matsya 6000 is an underwater vehicle capable of underwater travel to a depth of 6,000 meters. The underwater travel duration can be for 12-hour duration in normal conditions and 96 hours in abnormal situations. Matsya 6000 with 10 meters long, 5 meters height and 3 meters wide weighs 28 tons in air. It floats in seawater with a positive buoyancy. Matsya 6000 design has a 6000 meter depth rated watertight pressure hull or personnel sphere of 2.1 meter diameter which can accommodate 3 personnel. It has 3 viewports to allow personnel inside to view the subsea environment with the help of illumination provided by underwater lights. With the forward speed of 3 knots in water achievable using underwater thrusters, it can do subsea research, survey sampling and intervention. The ascent and descent motion of the vehicle will be given by the ballast and trim system, which is energy efficient. Matsya 6000 will be powered by lithium polymer batteries with an energy budget of 100 kilowatt-hours. Redundant control architecture and a fail-safe emergency and salvage systems will be the features of Matsya 6000 system. An A-frame-based launching and retrieval with support systems in operations research vessel Sagar Nidhi are envisioned for the Matsya 6000 system. India will be the 6th country to develop a deep-water research submersible along with United States of America, Russia, France, Japan and China.
Next. This slide shows that actually you name any submersible that is with Ministry of Earth Sciences. It's very rare to see that all submersibles, unmanned and manned submersibles, are under one roof. It doesn't, even advanced countries like USA and Russia, Japan, they don't have all the vehicles. But India is the only country to have all the vehicles. And recently we acquired one 6,000 meters autonomous underwater vehicle, which we have been using for underwater explorations. The second vertical is about development of ocean climate change advisory services. I present this on behalf of INCOIS. And these are the objectives. One is to facilitate climate change advisories for the societal and economical benefit of the Indian coastal regions. So it gives advisories about the frequency and severity of the cyclones and sea level changes and waves and how these parameters affect the biogeochemistry and other ecosystems and all. Actually, there may be a question why we should study these things. So these are the effects of anthropogenic and natural changes on our climate. To get this information, we have to study the deep ocean. People may say, what is the relation between the coastal advisories and the deep ocean? But as somebody said, if you really get a good weather information, you have to thank the ocean scientist. I don't know how many of us do it really, but we need this deep ocean information to get to give an advisory on sea level rise, intensity and frequency of cyclones, storm surges, wind waves, and how all these things really affect primary productivity and harmful algal blooms and all. So modeling and deep ocean observations are the key to successful prediction of these things. And the work is already in progress, and many models are tested and sensitivity analysis is done, and the occurrence and the track of the cyclone and the landfall, all these things are actually been, for the last so many years, it has been actually studied using the models which are shortlisted. And also in the, for predicting the extreme waves and the coastal erosion, many models were studied and some candidate models were taken. And the difference between the prediction and the actual occurrence was also studied to give a better prediction. And how is it done? It is done by better observations in the deep ocean. So far, we have been relying on mood buoys, but now there are many expendable or at least actually drifting buoys and gliders are used actually in the deep ocean to collect the information. Mood buoys are useful, but they are not just enough. So we have developed some drifter buoys also in NIOT, and we have transferred them to the industry, and we are working with INCOIS to deploy them in the ocean. And INCOIS successfully deployed many gliders and got informations. And many Argo buoys are actually, as a part of the international obligations, they are dropped in the Indian Ocean, and the data is being collected. And vertical 3 is about actually living resources. It is about biodiversity, mainly registry and repository of biodiversity in the Indian seas is being studied. There are 3 organizations Center for Marine Living Resources and Ecology, Cochin, and then NIOT and BARC from Department of Atomic Energy. They are actually participating in this mission. They have their task cut out. CMLRE is using remotely operated vehicles and all to collect the data from the seamounts and all. NIOT is collecting samples from the deep sea. Whenever there is a crew of using our ships, actually we go there and collect the samples, and some novel biomolecules are being cultured, and we are actually get a repository of microbial deep sea microbial systems are actually being set up, and DAE is concentrating on life-friendly molecules in the deep sea, for example, in the hydrothermal vents and all. And all means they are actually concentrating on that aspect, and also they are concentrating on corrosion at very high temperatures and very high depths and high pressures. So these are some of the things NIOT has been doing. We have got a high pressure system. When we bring the some kind of bioorganisms, actually, they die when we bring it to the top because they are actually piezophilic, or means they live in high pressures. So what we do is that we have made a high pressure sampler. It samples the water and brings it at a very high pressure. It maintains the pressure and brings it to the top. Even in the laboratory, we have a serial dilution facility where under the same pressure, these samples can be tested. And in CMLRE, actually, they are starting actually to collect the samples, and totally around 250 stereo models of many groups of deep sea fishes and crabs were actually created and used for training artificial intelligence and ML models. And Dr. Gupta, director of CMLRE, is here, and he knows more than I do about this one. And vertical 4 is about deep ocean survey and exploration. As I was telling, we have got one area given to us by the International Seabed Authority for polymetallic nodules. Another area is at 26 degrees south, which is actually 10,000 square kilometers is given. And it actually has these hydrothermal vents, as you know, when the tectonic plates meet, when there is a new pressure or something like that, hot magma tries to come out, cold water tries to seep in. When they meet, a geyser-like system is formed, and many precious metals in the form of sulfides and oxides are brought to the surface. And many chemosynthetic organisms are there. It's actually a beautiful ecosystem. But to survey this and find out, it's like searching for a needle in a haystack. You have to rely on some proxies, okay? And you have to look for them. And based on what, you have to identify either live vents or actually some kind of mineralized areas. When the vent dies, actually, the minerals that came, they form on the rocks around that one. That area is actually mineralized. It is actually future source of precious metals for us. So NCPOR Goa, they have been doing this work, and they are doing this kind of survey at these depths. And for this, actually, a ship is being acquired, which can really help us and actually steepen our learning curve and use, we do not have to depend on the foreign vessels for actually the survey and all. And we are in the process of acquiring this vessel as well. And as you can see, this is called Triple Ridge Junction, and there are around 100 blocks are given to us, and these areas are being surveyed now. We were supposed to give 50% of the area, that is 5,000 square kilometers, back to ISA, but on last Friday, some 2 more years of grace time is given to us by ISA because of this COVID and all. So we have some more time to complete our surveys. And as I told, searching for a live vent or a mineralized area at 3,000 meters water depth in 10,000 square kilometers area is a very difficult task. We have to depend on many proxies. And thanks to the efforts of NCPOR, many actually promising or actually candidates were identified, and almost more than 15 locations were identified where these vents can be there, and even the mineralized samples were recovered from there, which is very promising to us. And as I was telling, more than actually 10 locations show very high potential for the occurrence of either live vents or the mineral deposits. And this is the ship we are trying to acquire. Now we have got the quotes from two Indian bidders. It has to be made in India under Atmanirbhar Bharat actually. And we are at the verge of signing contract with one of the builders. And these are the specifications. It will have all the state-of-the-art equipment, physical, chemical, biological, and geoscience facilities will be there. And it will be an ideal platform for deploying various ROVs and autonomous vehicles and all. And vertical 5 is about energy and fresh water. As you know, NIOT has been working on this extracting energy and fresh water from the ocean. We started with wave energy. Later, we started working on ocean thermal energy conversion. That's the only renewable source which is available 24/7 to us. Ocean surface is at high temperature. At low temperature, means at higher depths, it's actually very cold. So if you can exploit this thermal gradient, you can generate fresh water and energy. We were trying to do it. We had some of our own mishaps there. So we converted that into a low temperature thermal desalination technique, which is suitable for the islands where the depth is available to the shore actually. Means around 500, 600 meters depth is available close to the shore. We have done this at this Lakshadweep Islands. We have already operated 5 plants and we are in the process of establishing 3 more plants there. But the technology used can be used for generating power and water as well. So we started actually establishing a plant at Kavaratti which can produce water, which can produce power, and that power can be used for running this desalination plant. That is, once we do it, this will be the first time in the world we can do it. But this technology is useful for the islands. What about the mainland? So it has to be done offshore, several kilometers into the sea. So we have to have a ship. We should have a riser system for sucking the water and all. So under this vertical, we are not going to make a vortex system, but we are going to do studies which can lead to ocean thermal energy conversion based desalination plant as well as the power plant. So the several designs have been already identified and we have been working on them. And we are also studying the riser system. It's not easy to have 1,000 meters long pipes which are of 1 meter diameter in the open ocean in all weathers and all. So it has to be analyzed before we really go into the ocean and do some kind of models and experiments. So this is working on. But you may ask, if you produce water and power at the hundreds of kilometers or tens of kilometers inside the sea, who is going to use it? Are you going to put a cable to the shore to extract it? Idea is that now there is a renewed interest in VOTEC because you can generate hydrogen there and that can be easily transported or it can be used for the visiting ships. We are working on this also as a part of this mission. And vertical 6 is actually, the objective may look very hazy, but if you ask me, this is one of the most important verticals of the mission. This will bring all the researchers, especially biology and marine biotechnology people who are working in different institutions and different fields. It will bring them together and it will monetize the results that are actually coming out. And it's a kind of a capacity building exercise to take tens of research scholars, postdoctoral fellows, and train them and bring all the institutions which are working on marine biotechnology on one platform. And we were trying to establish this at Goa, but we had some problem about the land and all. So we identified one land thanks to the efforts of NCCR Chennai. We could get a land in Vadanameli in Chennai, and we are going to hit the ground running and we are going to put up this facility very soon. But it will not be concentrated at one place. It's hub and spokes model. So it will be different organizations will be working at different places using this one. And the summary is like this. And Deep Ocean Mission is aimed at better understanding of the deep oceans, development of technologies for sustainable utilization of living and non-living resources. It has 6 verticals as explained, and it is in 2 phases, 3 plus 2 years, starting from 2021 and ending in 2026. The budget is around 4,088 crores, that is $500 million if my calculations are correct. And it's a multi-ministerial, multi-institutional mission. And we have been involving many agencies and many institutions, academia and all in these efforts. And it is in line with the blue economy and especially Sustainable Development Goals 14 policies and goals of the nation. We know it's a work in progress, and I have borrowed and modified the phrase from Robert Frost, and we have bottoms to dive before we sleep. Thank you very much.
Dr. R. Krishnan, Director, Indian Institute of Tropical Meteorology, Pune, for his address. Dr. Krishnan specializes in climate modeling to understand specifically the global climate change and variability, Asian monsoon, and the water cycle. He was instrumental in developing the in-house capability of IITM in Earth system modeling to address the science of climate change. Dr. Krishnan will talk about the Monsoon Mission, again a mission mode project of MOES, which has successfully completed 2 phases and has embarked on its 3rd phase. Over to you, sir.
Respected dignitaries, respected Secretary Dr. M. Ravichandran, former Secretary Dr. Sailesh Nayak, and all the esteemed dignitaries today who are present, directors of all the MOES institutions, all the senior scientists, and my colleagues and friends. First of all, I extend a hearty congratulations to the ministry on the 70th Foundation Day. And I also thank the ministry for giving me this opportunity to talk about Monsoon Mission. And as Secretary mentioned in his talk today, the skill of the weather and climate forecasts have improved over the last decade or so. And special thanks to the initiatives under Monsoon Mission. It has made a very, very important contribution in making this possible. And so when I was asked to give this talk on Monsoon Mission, for a while I thought about it. And I said, let me give an overall background to begin with, to highlight the complexity of the problem about the monsoon, predicting the monsoon on the different time scales, and how this mission was. So this was a very visionary move in going back in 2012 to envision this mission, which is also linked to the HPC requirements. And it's really a very complex problem. And as we have completed 2 missions, the first phase of the monsoon mission and the second phase, outcomes are very, very impressive. We also recognize that there are greater challenges, and now we are in the 3rd phase. So keeping this overall background picture in view, I thought I should give a background about the complexity of the monsoon mission, monsoon system itself, and see how to go ahead in the future and how we will be taking up the challenges, what is the scientific way forward. So with this, as I said, the Indian summer monsoon is really a complex dynamical system. And it is not just the atmosphere as it came out in the morning talks. It involves the ocean, the land, also the cryosphere, also the biosphere. And so these are all very interactive systems. And we are in a region where we are very close to the equator. And the equatorial ocean atmosphere dynamics, it's very, very complex, mainly because the Coriolis parameter is changing sign. It is negative to the south of the equator and positive to the north. So we have a 0 at the equator, which poses a lot of complex. I'll come to this issue. And so we have the land getting heated up during the pre-monsoon months, the Himalayas, the Tibetan Plateau, the ocean having a higher heat capacity, takes longer time to heat up. So a thermal contrast is set up, the pressure gradient is set up, and then, so because of the pressure gradients, the wind starts going from the high pressure to the low pressure. Then we have the effect of the Coriolis force, which is very important, especially in the context of the equatorial ocean dynamics. And then there is the evaporation of the water as the winds pick up the moisture from the Arabian Sea and the Bay of Bengal. And it also interacts with the orography of the East African mountains. I'll come to this. So these are mountains sitting right on the equator. So already we have a very complex system on the equatorial dynamics, and we also have the orography in the East African mountains. There's a water evaporating from the oceans, which is picked up by the monsoon winds. You have the low-level jet stream, what is known as the Somali jet, and then it interacts with these mountains along the Western Ghats, which is more of a gentle topography. And further east, we have the Burmese mountains, more rugged mountains. And then you have the formation of the clouds, clouds of very deep convective clouds, also the stratiform clouds of different types. And they organize over very large scale. And these clouds, when the water vapor condenses to form these clouds, they also release a huge amount of latent heating, latent heat of condensation. And this latent heat of condensation is now, we have estimates from the satellite. They can in turn feedback on the monsoon winds. So the heating due to the clouds can also affect the monsoon winds. And so there is a feedback, and then we have the precipitation. So it's really a very, very complex system. And not only that, as the monsoon winds interact with the East African mountains, we also have the coastal upwelling of the coast of Somalia and Arabia, which brings a lot of primary productivity, chlorophyll and nutrients to the surface. So the biology is also very much interactive, is a part of this whole system. So given this very complex, I would say, as a dynamical system in the equatorial region, and this is just to give you an example of the terrain in the East African mountains. Right on the equator, you can see this is the south of the equator and the north of the equator. This was a famous paper by T.N. Krishnamurthy about the three-dimensional planetary boundary layer for the Somali jet. So these mountains play a very, very important role. The frictional effects of these mountains, they are very important in accelerating the jet. And these are the meridional velocities of the coast of Somalia, East African mountains. You can see the wind velocities extending, very strong winds. This is the meridional wind section extending more than 1.5, 2 kilometers above the boundary layer. So it's a very important jet stream. And also, it is not just a balance between the pressure gradient and the Coriolis force. There are also inertial forces. So the acceleration becomes very, very strong. There's a near equatorial balance. So this is advective accelerations are very important. And this was a very nice paper by Hoskins and Rodwell and Hoskins. So when we look at the PV, the potential vorticity field, we can see to the north of the equator, the PV is positive. To the south, it's negative. And this is the zero PV line. So for the Somali jet to intensify, there is a PV modification is very, very important. And the surface friction of the East African mountains are very important. In addition to the land-sea contrast and the diabatic heating, the orography becomes very, very important. And this was an experiment. They showed that this is the observed reanalysis of the 850 millibar winds in the lower level. You can see the strong Somali jet. And this is a standard integration. And this is the integration without the mountains, East African mountains. So clearly the Somali jet weakens if you don't have these mountains. So they are very integral part of the system. So this is a very, very complex setting. And I especially like this picture by Professor Matsuno. So he talked about what is the difference between the mid-latitude and the tropics. It's a very nice schematic. He calls it as a two-world view. So one world we have in the mid-latitude, these big, very large-scale baroclinic waves, several thousand kilometers. They're highly predictable because the PV dynamics, the potential vorticity dynamics, is a very strong constraint. The PV is constant there. So the constraint is very, very strong. And so these waves are driven by the horizontal temperature gradient between the tropics and the high latitudes. So because of the temperature gradient, these waves are generated, baroclinic waves are generated. They're highly predictable because of this PV constraint. So the PV vortices, 2D vortices are predictable. And now we know mid-latitude predictions up to 15 days time scale. There is a kind of predictability limit. So they're highly predictable systems. Now coming to the equator, as I said, where PV becomes zero, so it is more soft and changeable. Also, this is a way, the equator is a region where it is dominated by convection. Lot of cloud systems they can form and they can organize. So the convection and wave. So there are different types of wave motions in the equatorial region and linked to the convection. And this is what he calls it as loose self-organization. So the equatorial region, tropics, it's a very, very different world. And whatever research has happened in the last 50 years in meteorological, we have improved the prediction of the mid-latitude systems. And when we come to the tropics, that is still happening. A lot of unresolved scientific questions are there because of this complex equatorial dynamics, especially the monsoons, and because of this PV equal to 0. And moreover, in the mid-latitude, people know how to, we have two classes of waves. One is the Rossby wave or the planetary wave, and these are very large-scale waves. And then you have the inertia gravity waves, and which are high-frequency waves. So in the mid-latitude, you can easily separate them. These two scales are easily separable, the inertia gravity waves and the Rossby waves. But in the tropics, they are not. At some wavelengths, in fact, there is an overlap between the inertia gravity wave and the Rossby wave. So those are known as the mixed Rossby wave gravity waves. They also become important for the prediction of some of these heavy rainfall events. So separating them or filtering them is not possible. In the mid-latitude, you can separate. And lastly, there is a connection between the clouds and the circulation and the winds. In the mid-latitude, the precipitation doesn't affect by and large. So it is mostly the horizontal temperature gradient. These waves grow because of the energy of this temperature, derived from the energy of these horizontal temperature gradients. But in the tropics, the diabatic heating, the latent heat released by the convection itself can feed back on the circulation. And so this makes the problem much more challenging. So I thought I should highlight this concept. And so this is just keeping the monsoon system in mind. And when this is the mean precipitation pattern, we can see precipitation, highest maximum precipitation along the Western Ghats and all over Northeast India. And also when we look at products like trim, you can see heavy precipitation along the Burmese mountains. And so this mean, of course, there are year-to-year variations in the precipitation. This is from 1871 to 2022. And many of these droughts, what we see, are related to El Nino events. Whenever there is a El Nino, generally we tend to have a drought, but not necessarily all of them. There are also exceptions to this. And this is a pattern. This was a paper by Vimal Mishra et al., where they made a maximum covariance analysis between rainfall and sea surface temperature globally. So this is the first mode. It shows that the precipitation decreases over large part of India. The first mode pattern is related to El Nino type of pattern. And then the second mode is mostly related to the Indian Ocean warming type of pattern. This is more like a break type of feature. And they have also explained what is the variance. So the variabilities are very strongly linked to the sea surface temperature variations, the monsoon precipitation variations on the interannual time scale. And of course, the Atlantic SSTs also have a role. And now this was another big discovery that happened in the late 90s, the discovery of the Indian Ocean dipole by Saji et al. It was a Nature paper. They told just like El Nino, we have a mode of variability in the tropics, in the Indian Ocean, known as the Indian Ocean dipole. And many of the strong events like 1994, 1961, also 2019, and possibly this year, we don't know. Looks like it may evolve into a positive IOD event. And many of these IOD years, we had received excessive rainfall over India, and this was one of our early papers. So because of this strong southeasterly trade winds of the coast of Somalia, they produce upwelling, they do bring cold water upwards, also nutrients and chlorophyll, and strong trade winds, easterly trades along the equator. So because there's upwelling cold water, and the SST is cold, becomes much cooler, and in the west there is more downwelling warm in sea surface temperature. Because of this continuous cold SST, you have high pressures, sinking motion, mostly clear skies in this region, and so you have a high pressure sitting over this region in the eastern Indian Ocean. Because of the high pressure, you have more outflow, and so the moisture, whatever is being taken out from this region, is kind of diverged out from this region. It feeds into the monsoon cross-equatorial flow, and you have a very active monsoon trough, continuously pumping moisture from the Indian Ocean to the Indian subcontinent and producing precipitation in large parts of North India, and also it extends even into the parts of the Indochina. And normally during some of these years, Japan receives less rainfall and you have hot summers. So I thought I should, so these are all very interconnected systems. And why I thought I should highlight especially the IOD is because now as we look, this is the latest picture, 23 July 2023, the sea surface temperature anomalies. We have a strong El Nino going on, picking up. And initially people thought the monsoon would be weak. Interestingly, what we are finding is we are about, now all India is about plus 6% close to, and from the later part of June, monsoon started picking up. We also see signatures of cold sea surface temperature anomalies just developing. This is latest picture. So let us see if this is going to, we are into a positive IOD and the monsoon is going to strengthen. That will be very interesting to see. So these are all, so the intraannual variations are affected by these various modes of variability. And there are also within the season, so we have this very large scale monsoon, the Somali jet, and we have this heavy precipitation anchored along the west coast of India, along the Myanmar coast, and over central India and the Himalayan foothills. And we have various synoptic systems by the low pressure systems, monsoon depressions, which form in the Bay of Bengal, move westward and produce rains. And we have also on the intra-seasonal low frequency timescales, this movement of cloud bands from the equator to the north. They organize over very large scales and produce precipitation. And also there are systems of coast of Gujarat and Maharashtra, coastal Maharashtra. They can give large amount of rain. These are known as the midtropospheric cyclones. Their signatures are mostly in the midtroposphere, but they can give huge amounts of rain, 50 centimeters a day or more. And these can cause flood-like situations. So these are all very, very important phenomena that is happening in this region. So the point I want to highlight is there are multiple scales that are involved in the producing the monsoon precipitation. This is a picture by Rao, 1981. So there are a lot of natural variabilities, a very complex dynamical system, variabilities on different time scale. On top of that, we have climate change. Now, human activities have led to this warming. The temperature of the planet has increased by close to 1.2 degrees, 1.15. And we know that this increase in the mean temperature is because of the greenhouse gases due to the increase in the greenhouse gas concentrations in the atmosphere. And we cannot just explain by the natural variations. And so what this means is, so when we look at the global temperature, we know from the models, we can fingerprint, this is the temperature fingerprint of the greenhouse gases. But there are other drivers in addition to the greenhouse gases, aerosol emissions from the northern hemisphere, which have dominated, especially in the 70s to the 90s. They kind of offset the effect of the temperature increase due to the greenhouse gases. They produce a relative cooling because most of the emissions of these aerosol particles, they have happened in the northern hemisphere. So the northern hemisphere temperature has been offset by these emissions compared to the southern hemisphere. So there is a kind of a interhemispheric gradient, more cooling to the north compared northern hemisphere, relative cooling. This is the fingerprint of the aerosols. And so one hemisphere is relatively cooler. The rate of warming is less compared to the other hemisphere. And when we see the precipitation fingerprints of these, the greenhouse gases, more or less we see an increase in precipitation in the mid-latitude, also the high-latitude regions, also over some of the monsoon because of the increase in the water vapor. But the subtropical areas, because there is stronger descent of the Hadley cell, many of the subtropical areas become dry. The aerosol fingerprint, because of this interhemispheric contrast in the radiative forcing, generally we know that there are theoretical arguments which show that the ITCZ will shift to the warmer hemisphere. So generally we see that the precipitation will increase to the south of the equator to the monsoon. So monsoons can be affected by the aerosols. So that is the point. So climate change is also one of the factors we have to keep in mind. So this is the assessment that came out from the IPCC. We have the global monsoon definition shown by the solid line. I will not go into those details. And we have the 6 regional monsoons, one for South and Southeast Asia. So in the historical past, I think the anthropogenic aerosols have kind of offset the precipitation increase that we might have expected only because of greenhouse gases. But in the future, due to reductions in the aerosol emissions, these long-lived greenhouse gases are going to dominate. Their lifetimes are going to be longer. So in the future, we expect the monsoons there more precipitation in the monsoons of Asia and West Africa. And interestingly, why I'm also highlighting is now we have different regional monsoons. The MOES also has funded an international monsoon project office at IITM to coordinate the monsoon research of all the regional monsoons. So it's a very visionary move. So why the reason is with this complex system, how do we predict it? Earlier, mostly the predictions of the seasonal monsoon was based on empirical methods. But now if you want to really go to a dynamical approach of predicting this very complex system, you need to go to numerical models. You need weather and climate models where, of course, you cannot solve it analytically or by a simple calculator. You need high performance computing. So typically the atmosphere and is discretized in the form of grids. And so when you make the grid smaller, you're increasing the resolution. Also, the time step becomes half of that. If you make the resolution half, the time step also you have to reduce it. And you have different vertical levels. So basically, these models, they solve these rates of the physical laws of the atmosphere, the equations of motion and the laws of thermodynamics, the equation of state and so on. And we are looking at the rate of change of temperature, pressure, velocities, humidity, rainfall. And it involves, so as you increase the resolution, the complexity, the number of points are going to increase. The time step is also going to reduce. So the computations will increase. And now, as I said, it is not just the atmosphere. We are also coupling it with the ocean and the cryosphere. So the computational complexity really increases. And so there is a strong link between dynamical models and the HPC. So the HPC augmentation in MOES was also a big strength in the success of the monsoon mission. So with this overall background, I thought this is the paper by Surya Chandra Rao et al. On the outcomes of the first phase of the monsoon mission. I think the mission statement is very impressive. It says the monsoon mission is a national program that has nurtured a system to provide skillful Indian summer monsoon predictions, benefiting society and advancing global climate science. It's a targeted activity to improve monsoon mission prediction across scales. And the ministry funded, the MOES funded this in 2012 to implement a state-of-the-art dynamical numerical prediction system. This is for the seasonal, on the seasonal time scale. Also an extended range prediction of the active and break monsoon, and an ensemble short-range weather prediction system using a high-resolution global model. And also carry out, in addition to these things, it was also envisaged that to carry out fundamental and applied research on the development R&D required to improve the model depiction and skill of the Indian monsoon. So very laudable objectives at those times, and we have come a long way. And now, prior to the monsoon mission itself, the skill of monsoon forecast was low in the ISMR, in the climate models. The correlation skill was less than 0.4, and there were problems in simulating the modes of variability, which I discussed earlier. And the IMD statistical models had limited success, which was moderately successful, and the limitations were recognized. And the skill of the IMD operational forecast at that time, 1998 to 2017, was about 0.336. And this is what the success of the monsoon mission forecast, what is shown in the blue line, with the observed precipitation. The correlation was about 0.54. So I would say this is a remarkable success, and this is a culmination. It's IMD, IITM, NCMRWF, and also INCOIS. So all these groups have put together this wonderful system leading to this enormous success of the first phase. So now one of the questions that arises, we are doing very well on the All India time scale. Oh, sorry. Yeah. So how about the spatial pattern of the anomalies, year-to-year variations? This is the June, July, August. I have not couldn't get the September. You can see that 2022 monsoon. This is the observed rainfall over large parts of Western India, even Pakistan. They had excessive rainfall and very heavy rainfall. The eastern parts of India, especially eastern UP, Bihar, and further eastwards in the Yangtze River Valley of China, they had a major deficit during that time. And this was the sea surface temperature. A very strong La Nina was there during 2020. And previous years, it was the triple La Nina, so cold sea surface temperature anomalies in the eastern central Pacific, warming in the western. And so precipitation reductions in the west, we can understand links to the La Nina pattern, and also increase in the precipitation in the equatorial Indian Ocean. And so by and large, the monsoon mission, this is the CFS V2, the previous 382 model. So getting these, it's able to capture some of the large scale signals associated with teleconnections. And of course, there are also differences, minor differences. We need to improve those factors as well concerning the spatial pattern of the anomalies. Still, it turns out that the monsoon mission model, the CFS model, which was with a lot of developments from the Indians and also under the monsoon mission project, the skill of the predictions have exceeded 0.6, which is really commendable. And not only the seasonal forecast, this is a schematic. We are also doing the extended range forecast and the short range. The seasonal prediction model had a very high resolution of about 38 kilometers grid scale. And the extended range model also did very well for the active and break spells. This is a resolution of about 110 kilometers. And the short range prediction, the GFS model, initially had a resolution of about deterministic, about 12.5 kilometers, and a probabilistic ensemble with 33 kilometers. And so I'm not going into the details. This was led by Dr. Sahai and team. Now Dr. Sushmita is looking after this ensemble prediction of the active and break spells. Up to 2 weeks over different parts of India, over the monsoon core zone of India and different parts of India, they demonstrated the skill of predicting the active and break monsoons, and also skillful predictions of the with the high resolution GFS model, skillful predictions up to 3 to 5 days of the heavy rainfall, and also some of the tropical cyclones I will be showing was achieved. So these are very important developments, and especially the improved predictions of the tropical cyclone. It led to saving of lives and some reduction in the property loss. So this is an example of a multi-week forecast of rainfall anomalies, again by the extended range group. I picked from this paper. So the active is an example of an active monsoon during 2 to 8 August 2019. These are the observed pattern of the anomalies, large-scale precipitation pattern. It is not just over India, as I said. You can see that it's extending all the way into Southeast Asia and to the Bay of Bengal. And so this is the week 1 forecast. It's doing a pretty good job. Of course, there is more dryness to the north. And week 2, this is a week 2 forecast. Although the pattern is seen in the week 2 and week 3, the magnitude of the anomalous increase in the precipitation, magnitudes are slightly weaker compared to the observed. So that is an area. So by and large, the model is able to get these big signals of the. Likewise, for the break, which happened during 12th to 18 July, you can see a large part of India reduction in the precipitation. The model is doing pretty good. Of course, there are differences in the magnitude, especially in the week 2 and week 3. We need to improve these aspects. So that is, but there's a huge potential. I see that. And when I look at the tropical cyclone, this is a prediction of one of the Nisarga tropical cyclone in 2020. And this was a GFS strike probability. It's doing amazingly well. And also, as I said, this is from the IATM GFS, IATM and IMD GFS strike probabilities, Arabian Sea cyclone. Also, NCMRWF this is a forecast of the NEPS global ensemble. This is a model with resolution of about 12 kilometers. This is the regional ensemble model, NEPSR, with a 4-kilometer resolution. You can see the strike probability forecasts are pretty accurate. And so I picked up this statement from Mahapatra et al. 2020. During the past 10 years, there has been significant improvement in the forecast accuracy of various severe weather events, including tropical cyclones, heavy rainfall, fog, heat wave, cold wave, thunderstorm, etc. And in particular, the track forecast error of tropical cyclones during 2015 to 19 has been 81 kilometers, 126 kilometers, 170 kilometer, as against 107, 165, and 230 kilometers during 2020 to 2014 for the 24, 48, and 72 hours. And yesterday I heard for the Biparjoy, the 48-hour forecast from NCMRWF was about 50 kilometers. That was very, very impressive. And so these are major improvements. Another major milestone that happened although it was not directly related to the monsoon mission. So when the monsoon mission project happened, we thought that we should have an Earth system model for climate change based on the CFS V2. And CFS was basically under the monsoon mission, which program with the NOAA and MOES. It was started in 2011. We said that, okay, why not have a model for climate change? And CFS model was, by the way, not a model meant for climate change. And many people even did not, they were kind of laughing, oh, what is this? Is a seasonal forecast model, how they can use it for climate change. So the first version of that model we transformed in 2014. We had a model where we could couple a new ocean model that was mostly in-house work at IITM, the CFS model with the MOM4 P1. And so that version had still, despite it could run successfully for more than 100 years. And but later on, we realized that there was a radiation imbalance, and we had to fix it. So for a climate change studies, the most important thing is we have to have a radiation balance, both at the top of the atmosphere and the surface, when you don't have any greenhouse gases or any anthropogenic drivers. And so we need to do these long integrations, what we call it as the pre-industrial control. And so we had to tune many things in the model, also improve the Arctic ice, this was mentioned, which was very much underestimated in the version 1, leading to major problems in the sea surface temperature and biases in the radiation fluxes. And we thought this, because of this excessive melting of the Arctic ice, the deep ocean circulation was almost practically absent. And this recognition of this problem, we addressed it. And in the version 2, we improved the Arctic ice by various, I'm not going into the details, and that led to a better representation, more realistic representation of the Arctic sea ice, the deep ocean circulation, and a radiatively balanced system of the IITM ESM. You can see still there are problems. There are issues with the Arctic we need to improve, but a major improvement considering from the version 1. And then we also made the historical runs and the future projections. And this went into the IPCC. The CMIP 6 projections were made based on the IPCC and for the IPCC. And one important thing is in the IITM version 2, we also have a very good, the monsoon also, the mean pattern, we reduced the dry bias despite having a coarse resolution. This was only a T62. Because we had to do several experiments and so we thought we'll go with a coarser resolution. Despite that, the monsoon was improved. One important thing, the IOD was excellent. I mean, this perhaps one of the best models, and coupling between the IOD and the monsoon stands out. Perhaps IITM ESM happens to be among the best. So the modes of variability, the first mode where we see a basin-wide warming, and the second mode where we have a IOD type of pattern, are very well represented in the IITM ESM. And also this IITM ESM also contributed to this MOES climate change assessment report, where we use the projections, global projections, both for the historical period and also the future. We compared with many of the regional indicators of change in the Indian Ocean region, including the sea level changes in the North Indian Ocean, SST, Himalayan snow cover, precipitation and temperature. Okay, so in short, what I would say is this is the summary of the monsoon mission phase 1, 2012 to 2017, where it's a collaboration among all the MOES institutions and motivated by India's need for global models to represent its monsoon better in order to improve forecasts and gain skill that was known to be possible to achieve. The monsoon mission program was launched in 2012 in less than a decade, fueled by the leaps in HPC and by its use of creative, not able to see that, creative researchers, creative league with motivated institutions. The successful implementation of the monsoon mission resulted in the following achievements. One, a new a high-resolution global coupled model is now operational, issuing operational seasonal forecasting of ISMR with high. It is also part of the operational seasonal forecasting system with high skills for the Indian region. A new operational extended range prediction system has been introduced. A very high-resolution probabilistic short-range prediction system, GEFS, with 12.5 kilometers and a deterministic GFS semi-Lagrangian 12.5 is providing useful skills. And so this is what I'm telling. So these activities, not only to reduce the development activities, were not only aimed at reducing the systematic errors, but also the prediction skill of the monsoon, weather and climate. Various phenomenological, several publications came out of this effort, of this important activity. And also the development of IITM ESM was a landmark contribution. And an important feature is the robust teleconnections of the monsoon with the Indian Ocean dipole. And it also contributed to the CMIP-6, the National Climate Change Assessment Report of the MOAs, and the IPCCR-6 Assessment Report. A dedicated HPC was developed at IITM. Initially, it was from 70 teraflop, it went to 790 teraflops for operational purpose. And for NCMRW 350 teraflops, it is further now upgraded with Pratyush close to 4 petaflops in IITM. And now it will be further increased in the coming year. And the capability was built for research in weather and climate modeling, various convective parameterization, cloud physics, land surface process. These were possible. And the NCMRWF unified versions were developed for different timescales, were developed for high resolution forecast. Also, air quality forecast was initiated. And in addition to the MOAS organization, participation opportunities were extended to various research and operational institutes by inviting proposals for overall improvement of the skills of the models. And MOAS funded in the phase 1 30 projects under Monsoon Mission 1. So following MM1, we had the phase 2, that was 2017 to 21. Because of the success of MM1, it enthused the government to embark on the second phase. Whatever gaps were there, it was gaps identified in the previous. It was decided that in addition to further development of the models at various scales, importance need to be given for applications. These were mostly focused on application demonstration models that could be used for forecast effectively. So emphasis on the second phase was given on agriculture, hydrology, and non-conventional energy sources, and also on improving the model dynamics, numerics of the CFS models, and also the prediction of weather and climate extremes. And the MM220 projects were funded, and these are some of the things where projects for the agricultural sector, the energy sector, non-conventional energy sector. And one of the important things that I would like to highlight during MM2 is the in-house development at IITM and the development of a new dynamical core based on the cubic octahedral. This we call it as the TCO spectral technique. This has been implemented in a very high resolution 6.5 kilometer model, and also the IITM ESM has also implemented. I'll show this. I think this is a very, very novel feature. And also in Monsoon Mission Phase 2, new areas were identified, including thunderstorm dynamics, for thunderstorm forecasting, air quality forecasting using high resolution models, using the GFS output as initial and boundary conditions. So I'm not going into the details of thunderstorm forecasting, air quality forecasting, and hydrological forecasting for short of time. So what I want to highlight is this TCO 1534, the triangular cubic octahedral grid. So maximum we have, this is the maximum zonal wave number 1534, and this is the GFS maximum wave number is 1534. But because of this, this TCO grid configuration, you get higher effective resolution at the equator, in the tropical areas. So this, even though the wave number is same, in the tropics you get an effective resolution of about 6.5 kilometers, whereas if the GFS it will be about 12.5 kilometers. And this is an example of a precipitation during 22nd heavy rainfall during 2022. You can see over central India, this is the observed rainfall. Of course, I think the observed rainfall appears to be, from what I see, is in centimeters per day. Please correct me if I'm wrong. The model is getting those values even in the day 1, day 3, and day 5. Compared to the GFS, it does a better job. But there are also, I see some issues. For example, the rainfall in the Burmese mountains are not seen in this. Probably that is something we need to improve. And so the magnitude, the locations, the heavy rainfall is seen in the model, but the amount is still is kind of underestimated. So TCO shows very heavy rainfall till 5-day forecast compared to the GFS, but we still need to improve on the magnitude. And so this is the TCO grid I was talking about in the IITM Earth System model. We had the T62 model for the atmosphere with 192 and 94 grid points coupled to the ocean. This is the resolution 2 degrees per day. And typically we used to do about 8 years of simulations per day. Now this is an example of the TCO which we are already implemented. We have more number of grid points for the same wave number with improved resolution at the tropics, higher effective resolution, and also computationally it's much more efficient. And for the CMIP 7, CMIP 6 is over, now we are going to the CMIP 7, we are increasing the resolution to TCO 126, that's about 67 kilometer grid. So this is the plan for the CMIP 7. I will not go into the, so it is already started. We need to do the DEC and the community MIPS. And so these are some of the ongoing developments. I thought that Surya shared some of the slides. Monsoon mission now presently there, the previous version 1, we had the GFS model at T382, about 38 kilometers grid. They are planning to go for a T574. They have done some hindcasts. It's interesting. Also, this will be using the MOM6. There are some interesting improvements. Although some of this precipitation during 1998 is kind of overestimated. Also, I found that 2019, which received one of the heaviest rainfall in recent times, India, there's a kind of, the model seems to underestimate. We need to really look at why this is happening. And also we need to ask the question whether improving the high resolution for the seasonal scale, the spatial pattern of the anomalies of, is it going to improve compared to the T382? So some more research work is needed. I think this paper is under submission. And for the extended range prediction, they are doing a multi-physics framework where they are generating ensembles based on multiple physical parameterization scheme and different initial conditions, and to produce probabilistic forecast. And now they have 18 members based on multiple physics and multiple ensembles. And apparently there is improvement in the week 2 and also week 3 forecast for the above normal and below normal rainfalls at district level. So this work also, we need to also evaluate it. And the IITM ESM development and future plans ongoing. We have a IITM ESM TCO 126, that's a 67 kilometer. We have already, with the coupling with MOM4, P1 is working. We are going to try MOM6. LULC, land use 24 vegetation types. We are including the Greenland ice sheet because that's one first time we are including, because that region, the ice sheet has been melting. And aerosol indirect effects are being incorporated the first time in this model, as I said, because they do have an impact on the temperature. And the post-processing is a big work, diagnostics. And future plan 2024, we will finalize the model for CMIP 7, implement LULC, Greenland ice sheet melt, indirect effect, freeze the CMIP 7 version. And future plan, we also want to go to try to increase the resolution further, Antarctic ice sheet, Himalayan glacier, MOM6 coupling, and beyond 27, land carbon cycle and interactive aerosols. That's the plan. Now, questions is the key question is extremes are becoming, extreme precipitation is becoming a big issue. How to improve them in a changing climate? So this is from the IPCC. We know that with increasing temperature and increasing warming, not only the temperature increases, extremes are also projected to increase. So what was happening once before is now projected to increase. The warm extreme temperatures are going to become 2.8 degree times more in the 1 degree warming. With higher warming, this is going to increase. This is on a global context. And also heavy precipitation events are also, which is for 1.5 degree for warming, global warming, precipitation extremes will be 1.5 times more likely compared to the past. And 1.5 degree warming is expected in the next 15, 20 years or so. So this is now this is fine because most of the increase in the heavy precipitation, precipitation increase due to climate change is understandable, but when we look at some of the regional extremes, they are not only linked to the temperature increase, but they are also linked to the circulation changes. For example, some of the heavy rainfall, even recently we had heavy rainfall over parts of northwest India, and typically the MTCs which form over the region of, this was a work by Keshavamurthy et al., Miller and Keshavamurthy, that during the International Indian Ocean expedition, they documented these mid-tropospheric cyclones. They are almost stationary. You don't see the surface signature, but they can produce really very, very heavy rainfall. And now we have some information about the latent heating thanks to the TRMM data. We have an understanding why these vortices are centered in the mid-tropospheric level. And when we see, this is a typical example of a MTC event on 25th June 2006. We can see convection, very heavy precipitation in this region, but it's really a large-scale organized convection extending into the South and Southeast Asia, and there's deep embedded convective systems. And the question is, this is a paper from an interactive web atlas by MAPES. The heavy rainfall amounts during these heavy events over Western India could be of the order of 700 millimeters in 3 days. So this can lead to massive flooding. This is over a fairly large region. And so how do we understand? So it's not only the changes in the temperature and the thermodynamics due to the increase in the water vapor, but also the effect circulation changes. And also this was an extreme event in Uttarakhand during 2013, June. We had this low pressure system going from the Bay of Bengal into that region. It moved quickly, very early. It was a very early monsoon onset. Also, there was a very deep trough in the mid-latitude westerlies, and this was extending even in 500 millibar, 700 millibar. And so this interaction with this low pressure system triggered huge amounts of rainfall and led to this massive flooding. So rainfall amounts, you can see many places they exceeded or many stations, they reported more than 300, 400 millimeters of rain in a single day. And so they can lead to massive flooding. And this was the Kerala heavy rainfall in 2019. 2018 had also previous year big rainfall and flooding for the entire state of Kerala. So this was during 8th, 9th August 2019, courtesy Partha. So these heavy rainfall amounts, 150 millimeters in a single day. And the models they are picking, but definitely getting those type of big numbers. I think we still, the model forecast even in a 24-hour, for they fall short of the magnitude of rain. We understand that we have to keep that in mind. And CMIP models, we also know that they have large biases in the South Asian monsoon precipitation coupled models. This has continued from even in the past. We are trying to improve this. So once we have bias in the precipitation in the model over a large, there's a deficit, we introduce large precipitation bias in the latent heating. So there could be circulation biases. And then you affect the introduced bias in this circulation and then lead to biases in the sea surface temperature gradient. So this leads to a kind of vicious cycle. So we need to address these challenges. So there is an urgent need to reduce these biases in the monsoon and tropical precipitation. So what is the way forward? So there is a view that we need to go to kilometer scale models. Can they solve it? Some groups are trying this. Now some people are thinking that maybe use high resolution models, also bring concepts of AI, ML, machine learning with available data to improve. So these are all various experiments going on. So clearly, improving predictions of monsoon weather extremes in a changing climate, there is scope for further R&D activities. We have made significant progress in monsoon mission, but it's also important for us to recognize that some of these issues about the heavy rainfall, underestimation of extremely heavy rainfall in the models from the GFS, we need to work on that. And it's almost 1 order magnitude many times. And how do we do that? Whether it could be through the improved data assimilation, we have a huge amount of radar data now, can we assimilate that? And new satellite products, I think NASA is coming out with this wind mapper, where they're having both the winds and the moisture fields. And we could also use innovative techniques like AI, ML, and deep learning. And also there were new projects like the CAPEX and other at the high altitude cloud physics lab, where a lot of interesting work came out on the cloud and aerosol interaction, the microphysical and warm rain processes. Especially in the Western Ghats, the clouds may not be very deep. Studies have shown that, but they produce huge amount of rain. These warm rains, and several studies have shown that. So we need to really understand how these warm rains are continuously producing rain lasting for several days. What is the role of the aerosol and cloud interactions? So there's a lot of scientific questions that need to be addressed. And how these mesoscale convective systems, the example that I showed, how they organize over scale of several thousands of kilometers and rain bands during active monsoon. And this is because this is important for improving the three-dimensional structure of the latent heating, the stratiform and the convective clouds, and also the ocean-land atmospheric coupled exchange of fluxes of heat and moisture. We need to improve that. There could also be new sources of monsoon predictability on the subseasonal timescales beyond sea surface temperature. It could come because of the soil moisture variations. What is the effect of the soil moisture over India and or Asian region on the active and break monsoons? And also these big volcanic eruptions, they're happening. Like the Pinatubo, we had, and they inject a lot of aerosols into the stratosphere, some of these big eruptions. And once these aerosols enter the stratosphere, they can stay there for a couple of years and they can affect your radiation and they can affect. So that also is an important source of monsoon predictability on the and the seasonal timescales. We need to really do a lot of work. And so with this, I want to, we need to interact with the academia, with the research institutions, and these are all important questions. Summary, monsoon mission and improved monsoon predictions. Accurate predictions of monsoon rainfall is very crucial as it impacts many sectors like agriculture, water resources, power generation, transport, even the Indian economy. The monsoon mission was launched in 2012 with an allocation of 400 crores to develop the capability and dynamical model prediction systems for short range to seasonal forecasting and to improve the monsoon seasonal forecast. Under the monsoon mission, these initiatives have helped to improve the skill of monsoon forecast over the country. For the first time, the IMD included the operational monsoon mission dynamical model forecast to prepare operational seasonal forecasts in 2017 monsoon rainfall over India. India's first Earth system model contributed to the global and regional climate change assessments of the IPCC and participated in the coupled model intercomparison program, CMIP6. And these were the IITM ESM projections were used in the MOES National Climate Change Assessment Report, which documented climate change projections over the Indian region and was released for the benefit of students, researchers, and policymakers. After the success of MM1, the second phase was launched in in 2017 with the objectives of developing suitable applications and also to improve the predictions of weather and climate extremes. A noteworthy contribution during MM2 is the in-house development of a new dynamical core, which is implemented in the high-resolution global weather forecasting system. It's a 6.5 kilometer model and IITME some 67 kilometer grid. In addition, MM2 witnessed significant developments in new areas of forecasting applications, such as thunderstorm forecasting, air quality forecasting, using high-resolution models with GFS output as initial and boundary conditions. Monsoon Mission Phase 3 was launched in 2022 with emphasis on extreme weather forecasting, and development of application was sector-wise weather forecasting requirements. We also recognize that there is scope for further R&D work to address these key scientific challenges, and we need to collaborate with everyone. Jai Hind, Dhanyavad. Thank you.
Dr. Tamban Meloth, Director, National Center for Polar and Ocean Research, is an expert in the area of climate variability and its impact on glaciers. He has undertaken several expeditions to the Antarctic, Arctic, Himalayas, and the Southern Ocean. I welcome Dr. Tamban to share his insights about the Arctic exploration of India.
Thank you, Shekhar, for that introduction. Respected Secretary Dr. Ravichandran, respected former Secretary Dr. Shailesh Nayak, who also happens to be the chairman of the Research Advisory Committee of the National Center for Polar and Ocean Research. So what I've been asked today is basically to give a small brief about what are we doing in Arctic, the Arctic exploration, our endeavors, and what are the new things we are trying to do. So looking at the new frontiers. So as many of you would be knowing, the National Center for Polar and Ocean Research is essentially an institution looking at one of the important component of the Earth system science, that is the cryosphere as well as the ocean. So if you look at the cryosphere itself, when you talk about the cryosphere, it is that part of the world where mostly ice is found in frozen form. Like Antarctica, for example, one of the largest cryospheric component, which is a continent of nearly the size of about 4 to 4.5 times of Indian subcontinent. A continent surrounded by ocean. A continent which has an ice as thick as about 4.5 kilometers some places. And then you have this Arctic in the northern hemisphere, essentially an ocean surrounded by continents. Most of the living places where people are there. And the Arctic Ocean also has an important area, which is the water which is frozen, what we call as sea ice. Sea ice, which is a multi-sea ice, not just sea ice, which is actually forming what we find seasonal as we find in Antarctica. So these kind of things makes these regions very highly different from each other. So whenever we hear about the polar regions, they're all not same. Then you have this third pole, or what we call as the Himalayan region, which has a large number of glaciers and the frozen land. So if you look at the IPCC recent report, one thing is very obviously very clear that almost all components have been drastically changing over the last several decades. And we reached a situation where this CO2 concentration is the highest in the last 2 million years. The sea level is rising in the fastest in the last 3,000 years for that matter. And we also have Arctic sea ice is disappearing, which is found in the lowest level at least for the last 1,000 years. And the glacier retreat, especially the mountain glaciers retreat, has been unprecedented at least for the last 2,000 years. So all this makes a very complex scenario for how we look at what is happening on the globe. Especially if you look at the Arctic, the warming impacted the Arctic much, much more than any other part of the world. If you look at globally, we know that this global warming is a reality as of now. But if you look at the Arctic region, the warming is nearly 3 to 4 times of the global average. We have Arctic amplification, something we call actually that unusually warming happening in the Arctic region, which has a many scientific reasoning to it, from mostly the ice albedo effect actually, because as the warming is taking place, ice is nearly about the 80 to 90% is reflecting back the solar radiation. Compared to that, the ocean, 80% of that is being absorbed. So the moment there is a warming takes place, this as glaciers, the sea ice start slowly melting. It is that is becoming more absorbing in nature. So then, as it absorbs more, it starts warming more. Again, you have more melting of ice, and it's a vicious cycle. It's a positive feedback as well as a vicious cycle which is happening. As a result, the Arctic is becoming unusually warm, and the rest of the world. If you look at the sea ice conditions actually all across the, since availability of the satellite data, it's been dramatically decreased, which has reached to, nearly about 13% per decade. And the ice sheet, which is found in the Greenland, the part of the area where you still find land ice, it's melting very so drastically and losing mass, by an alarming rate for the last, at least for few decades. All these are making, you have a freshwater input coming to the Arctic Ocean. You have the sea ice melting, and it's making so, the dynamic in the way that actually, there's for the lot of river water coming in and making very complicated scenario which Arctic never faced in the past, at least in the recent memory of mankind. Therefore, all land surface components, including that of the permanently frozen land, what we call as permafrost, has been decreasing drastically. If you look at the picture one, which you can see actually that been ever since the satellite data has been available, what we find is a warming of Arctic taking place also on the land. As a result, the permafrost is actually thawing. We also find the greening of Arctic. The Arctic is becoming more greener and greener. And as a result, all these are actually becoming a very, interacting with the global systems, making it very highly, complex in nature. So Arctic is not, what happens therefore in Arctic does not stay in Arctic. It has a global connection, it has a global linkage. So it is not only just, it's the loss of sea ice and the related circulation effects, but also it has an atmospheric connections. As most of you sitting here also know actually that Arctic has a direct connection to the monsoon climate system. What they call actually is the atmospheric bridge. It is also an ocean connection. So making all this actually are, the time scale connectivity happening between the Arctic and the rest of the world. And as I said, actually, as the Greenland and some of the regions in the Arctic is melting more, there's a lot of water is coming to the Arctic oceans. So the river discharge is also making it the oceanic circulation very different than what we see today. So how are the warming is really impacting our day-to-day life? It's already showing that impact. Temperatures, for example, less ice because of the warming means you can have a more what we call the reduced albedo, which also means that extreme winters as well as the polar jet stream will be also destabilized by warmer air, and it can also meander south, as we have seen actually in case of this. We were talking about even Uttarakhand flood, which I was talking about. So such things are quite commonly happening now. It can also impact the coastal communities. Coastal communities because the rising seas as well as endanger a lot of coastal cities, and many of the small island nations, for example, are having coastal flooding and storm surge. And the food, it can also impact the food because as the polar vortex actually increases, the heat waves are increasing, and therefore the unpredictability of weather is causing significant damage to the crops across, as you must have already seen it. It can also impact the shipping because as the northern hemisphere ice is melting, it's going to increase the shipping activities in the Arctic region. It may look like a positive aspect because you're going to have more business, you're going to have more economical aspects. But it also brings a lot of environmental dangers because the melting Arctic leads to increased the ships going into Arctic, unknown territories with increased dangers to this one, and potential oil spills as happened in a couple of times. And oil spills happening in those kind of places are impossible to actually address to immediately compared to the rest of the ocean. And it can also impact the wildlife, as you already seen actually loss of ice and the habitats. Many of the habitats which is actually sea ice related habitats, like for the polar bear, permafrost, all this actually spells a lot of trouble for many of the lives and leads to a conflict. They will first come in contact with the human life, then they will also conflict. This is very already seeing in some part of the Arctic. Finally, the permafrost. So Arctic permafrost is something actually we are taken for granted for a long time. It also has a large amount of methane we released, and as the permafrost is being thawed, which can also increase the the increased methane to the atmosphere, leading to a rate of warming, as well as a lot of localized as well as regional problems like the construction problems and civil engineering problems and a lot of issues related to that. So if you look at the National Center for Polar and Ocean Research, which was created actually as an Antarctic Study Center to just to carry out Antarctic expedition, become a research institution to also study the Antarctica and related ocean aspects. Then it became a polar institute so that we are able to expand our activities beyond the shores of Antarctica. Currently, if you look at, we have several, we started in Antarctica way back in 1981. In fact, the parent institution of this Ministry of Earth Sciences, Department of Ocean Development itself is created for the Antarctic expedition time. So as a part of our first venture into Antarctic expedition, Department of Ocean Development created, which now become the Ministry of Earth Sciences and looking at the much larger aspects than what we used to do it. And therefore we have now increased activities happening in Antarctica. We have currently 2 stations in Antarctica. Both are wintering stations, that means year-round stations, called Maitri and Bharati. And Bharati is one of the most modern stations in the entire continent. In fact, as Dr. Jagveer Singh was just reminding me, we have a constant interaction with students with Antarctica using Bharati Station because it got a lot of modern facilities. Today, for example, 30 schools have been interacting on this day of Foundation Day. 30 schools have been interacting with Bharati Station and the scientists working over there, as well as the technicians working over there, learning from their experience how the life would be and so on. In fact, we have a target of 7,500 students interactions before 15th of August. We will be completing that, in fact, today. So we are already ahead of our schedule. So this is something actually being also used as an outreach platform. In Antarctica, we also have been to the South Pole, which is a geographic South Pole, which is about 90 degrees south. The Antarctic stations are mostly along the coastal regions because of the accessibility in terms of supply and so on. Like, for example, Maitri is about 70 degrees south, whereas this is somewhere close to that is about 90 degrees south. And NCPR also has activities happening in the Southern Ocean. It's the ocean surrounding the Antarctica. And as a recent deep ocean mission was, as pointed by Dr. Ramdas, we have a serious deep ocean research project going on in the mid-oceanic ridge of Indian Ocean. And in Arctic, we started way back in 2007 as a small expedition to the Svalbard region in Ny-Ålesund region. Now we set up a small station called Himadri there in 2008. And we have moved to now also Canadian High Arctic starting from this year. There's also a lot of activities happening in collaboration with some of the countries in the Arctic Ocean. And last year, in fact, some of our colleagues had an opportunity to also touch the North Pole. So we are therefore a kind of a really global institutions dealing with from the deep ocean to upper ionosphere and so on. So almost every aspects we deal with, although it's a small institution. So if you look at the Arctic, our initiation, as I said, we started in 2007, and by 2008 we already have a small station there, and it's in a place called Ny-Ålesund. It's part of the Svalbard region, which belongs to the Norway. And as part of the party to the Svalbard Treaty signed in 1912, India has an access to that particular place. And we also have, I said actually, we also had an opportunity to reach up to North Pole already. Some of the scientific thrust of in this region, based on the limitations of the space, accessibility and so on, has been mostly on the marine science, atmospheric science, environmental studies, and cryospheric studies, and some amount of geoscientific studies. These are some of those pictures actually what our people have been carrying out there in Arctic. And some of the major activities, and if you look at it, we had nearly about 200 small projects happening there actually. Mostly it's annual. We provide NCPR as a nodal agency for the polar expedition, provide opportunities for people to conduct field expeditions. So that's what I'm talking about in this case. Mostly related to, the oceanography, geology, glaciology, and biology and biogeochemistry. Biology is one of the big strength of Arctic studies because you don't require a lot of logistic facilities for biological sampling compared to many other projects. And atmospheric science has been another important area. We hosted nearly about 400 people, Indian scientists in this particular station for this since we started in 2008. We also had, quite a important, publications coming out of this, this particular studies. More than 150 publications came out of it. And so far, we have been restricted to Svalbard region, which is, at about 79 to 80 degree north. And mostly summer months, because the winter time is completely dark and it's unable to carry out research in when you go out. So, however, for starting from this year, actually, we are also expanding to our winter, expeditions, essentially looking for allowing the atmospheric scientists, people, like to study about the auroras, and people like to study about the upper atmospheric processes and, the ionosphere and so on. And from this year, we are also expanding to beyond the Svalbard, going into Canadian high Arctic as well as potentially to Greenland. So these are some of those activities we started working on in the marine science. Most of the studies in the beginning has been restricted to the fjords. Fjords are nothing but like a glacier enter into the ocean. There is a small area like, these what we call as estuaries, something like what we happens a river enter into an ocean, estuaries. So fjords are something like that, where there is a complete dynamic, interaction between the ocean currents as well as what is happening on the land. And they provide quite a good, important messengers of how in the changing climate, how the oceanic waters incurring into the fjords compared to that in the past and so on. And we also have a small mooring system, what we call as INDAC, on this fjord. This fjord basically is an ocean mooring system in this case, which is essentially for the hydrographic studies. We have a continuous, on a temporal, resolution monitoring of it, with essentially with both physical as well as biogeochemical, sampling, basically sensors, and which led to us to help study the ocean warming happening, the freshwater discharge coming into these areas happening, as well as the especially Atlantic water incursion to these fjords. So that's the picture which shows actually what is a typical thing we put up there. But as we plan actually in future, we also plan to have a mooring happening in the deep oceans, because we want to go beyond the limitations of the logistics and trying to do research which is a little more complicated area, as we are gathering more confidence as well as our abilities are being increased. So I also would like to just point out some of the research activities we carry out here, and some of the highlights, very recent, the latest results actually. So one of this is actually what we found actually the warming as well as salinification of some of these fjords happening. As I said, actually, as the Atlantic water is getting, I keep talking about Antarctic because I deal mostly Antarctic. Sorry for that. So when I'm talking about Arctic, it is not Antarctic, it is about Atlantic. So Atlantic water keep incurring into these regions. This is one of the study which clearly showed that we have a increased warming happening in some of the fjords, and increased salinification since 2000, because we have now kind of data available, and it has regional as well as actually local implications. And we have also these the community studies, especially microbial community studies, and the dynamics we study, which clearly show that there's a high diversity of coal-loving bacteria in this region, which can degrade organic matter, and also increased organic matter supply stimulated few of the bacteria special groups, which increasing the carbon turnover and nutrient utilization in the fjords. So the bacterial community showed the depth-dependent distribution, less vertical interconnectivity, indicating more utilization as the waters are changing. In the atmospheric science, as I said, actually we also have an atmospheric laboratory over there, observation system, where we carry out a continuous monitoring of aerosols and black carbon, precipitation measurements. For your information, the Near-Eastern is a place where various countries are already there. There are a lot of countries existing, so we cannot carry out any of the research which we simply would like to carry out. It has to be discussed in a Near-Eastern Science Managers Forum, where we can't duplicate the science which is happening there. So we are only basically looking at those areas where we have certain amount of expertise within the country, as well as there's no one else is really working on this. So therefore, whatever I show here actually are basically kind of a research which is actually kind of unique, therefore. So these are some of the, kind of the, the research outcome which we, came out of Arctic. For example, in this case, actually, this is, Arnav Mukherjee and Dr. Ravichandran's paper, actually, where they talk about a new, model which they try to couple with, to understand the sea ice variability. And this is one very interesting paper happened in 2022, actually, where we are trying to, one of our youngster, Saurav Chatterjee and the team actually come out with a possible relationship between the Arctic sea ice as well as the late season, Indian summer monsoon rainfall extremes. What they find is that Arctic sea ice extent is negatively correlated with the frequency of, extreme Indian summer monsoon rainfalls. Lower the sea ice, you have the higher the frequency of extreme events happening there. So these are something which, we came out of these studies. And geoscience is essentially people study, they collect these sediments as well as sediment records. They try to study the, past climatic variability and then try to interpret in terms of actually how, how things have been completely different when the system, the climatic system was completely different. And what were those tipping points in those climate system which could have implications for as we are getting into, the carbon dioxide, crossing 420, ppmv already and getting into more, extreme conditions. So this is one of those publications actually of our, Vikash Kumar and from NCPR, wherein actually they find actually a warmer Arctic leads to stronger Indian summer monsoon, rainfall. Especially especially this, this study deals with the last 1,000 years with a high resolution possible, in the sediment records. They use not only proxy record, they also like, the AIML to understand the potential, internal variability existing them. And the proxy records clearly reveal that actually warm Arctic intervals during the last millennium were associated with relatively enhanced summer monsoon precipitation. And the modulation of meridional thermal gradients of the Indian monsoon domain is basically the main key factor they found actually as the reason for it. So it shows a very clear, implication to the, what happens in the monsoons and that region. This is another important paper which, published recently again, in the AGU journal, very high impact journal, wherein they found very low sea ice and Arctic sea ice, as well again connecting to a stronger Indian monsoon. So we are getting more and more results in the past, clearly indicating actually that there is a sea ice has a direct link with the Indian summer monsoon. In this case, they are talking about a story which looks really old for you because more than 3 million of year old, sediment record. But the importance of that 3 million year old record is that actually it represents the mid-Pliocene warm period, which is considered to be the modern kind of analog for the modern climate system what we are now because of the carbon dioxide as well as many of these sea ice conditions and all what we see today. And what they again find actually the lower the Arctic sea ice leads to stronger South Asian monsoon, during this particular period, which has again implication actually as we are getting into that kind of system. So these are some of those very brief kind of science which came out of Arctic, which I just wanted to be restrict due to limited time. So I'm not explaining a lot of other things. In the coming few slides, I also would like to just to give you some ideas about the new frontiers we are looking at it. We want to go beyond our logistic operational limitations, looking at collaborations, possibilities to join international teams, international projects, so that you have a bigger visibility as well as the bigger science you are able to do it. In this regard, we had one of the small expedition happening along the Svalbard along the coast in 2019. Then we had an Arctic Ocean cruise in collaboration with again Korea. Some of our scientists could participate and collect samples during that time. And recently, we had an opportunity because the Norwegian Polar Institute has a new icebreaker vessel dedicated mostly for the Arctic. So we have, with a good collaboration with cooperation with Norway, we are getting opportunities almost annual basis. In fact, getting into those expeditions. So the RV Crown Prince Haakon actually had an expedition going on every year now to the almost close to the North Pole. In fact, 2022 it touched the North Pole. This year, because of due to the heavy sea ice conditions, they could not go to further north. They rather restricted themselves into Fram Strait. So these are opportunities just coming in collaboration. I think that would increase our opportunity to get address the larger scientific problems, as well as in the process also enhance countries' image within the Arctic, the rim countries. As we are looking forward, as we have an observer within the Arctic Council, we also have a real interest as well as duty to enhance our visibility there. So this is a new frontier we are looking at actually in the Canadian High Arctic, because as I said, Arctic is a very large area. We are still restricted to a very limited area because of the very lot of complicated logistics involved. So from this year, we will be expanding our activity in in a small way again in the Canadian High Arctic. There is a station called Canadian High Arctic Research Station. So there have been many agreements. There is an MOU already signed. We also have a lot of indigenous communities over there, which means that actually you cannot carry out any research activities as you do in Antarctica, not even as you do in Svalbard. We have to carry out a research which supports the indigenous communities, the Inuit community, as well as the community which they desire. So if you want to carry out any research there, we need to convince the community there first, actually, okay, this research is going to be of useful for you. So that's how it takes a lot of licensing and other thing and all. It's taken several years for actually, although it started way back, and Dr. Ravichandran was the director there actually. So it took COVID and thereafter, so all this kind of licensing took many more years. But I think it's becoming a reality now. So this particular year, we are already starting from August and September. And we are also at very international Arctic forums, because Arctic is also, the polar studies are also about not just about science. It's about how you effectively enter into the policy domain, effectively get into strategic, the places where, it makes countries, place properly. So we are an Arctic Council observer since 2013. And therefore we have to do certain kind of activities continuously to ensure that actually that is being maintained. We are also quite active in Arctic Circle assemblies and forums. We are very much active in the International Arctic Science Council and its working groups. And we joined the Svalbard Integrated Arctic Earth Observing System, what we call as SIOS, in 2019. We are a member to the Nielsen Science Managers Committee, because as I said, any activities carrying out in Svalbard has to go through this particular committee. It has to be cleared by the committee, then only you can carry out any research there. One way it is extremely good, because although you don't have the kind of freedom which you can do in Antarctica, but it also ensures that you don't duplicate the other activities. And we are members to so many other agencies. And to top up all this, India government came with this Arctic policy, because as the Arctic is becoming more and more important for as a nation, as well as it's not only just scientific interest, it also has an important policy requirement. So Government of India came up with this Indian Arctic Policy 2022, which rests mainly on 6 pillars. First and foremost, science and research will decide our main activities in the Arctic. We will contribute to climate and environmental protection in all possible ways. We will also look forward to economic and human development as a country as we're growing. We certainly look forward to transportation and connectivity, because as Arctic is melting, there are opportunities for increased, the northern sea route is being opened. And in that case, actually, we should be having some say in that. We also want to be involved within the governance and cooperation within Arctic region. Although the governance currently is only basically Arctic, the council countries, because only the Arctic realm countries. But it's not only about just Arctic countries, because also it's going to affect the whole world. So you need to have a say in that. Ultimately, we also want to develop national capacity, as we want to become we are not a polar nation. So therefore, it's extremely important for us actually, as we go forward, we keep developing this expertise and develop into many of the academic institutions, universities, small institutions, that slowly into the education systems and so on. So that's how we, ultimately we want to be, our vision is basically to transform Indian scientific endeavors across the Arctic, expand our approach on a pan-Arctic perspective. We want to increase our presence in Svalbard and rest of the places. We also want to, establish a network of observatories to study the land-sea atmosphere cryosphere interactions. Because as we all know very clearly now, there is a clear demonstrated this one between Indian monsoons and the Arctic region. So how do we study this? Unless we have a kind of a series of observation systems there, actually we are never going to make any contribution to that. We also want to have a sustained scientific observations in the Arctic Ocean, because Arctic Ocean has been an extremely what you call no-go area for us for a long time, but we are slowly getting into that actually in collaborations. We are slowly getting into the possibilities, and that is bringing a lot of good science for us, because we wanted a larger domain to, if you want to have good publications coming out. And sustained engagement in the Arctic Council and other various Arctic forums are, important for sustaining India's strategic, interest. I think that's all I want to say. Thank you so much.
Thank you, sir. Dr. Sukanta Roy is Scientist G and Head, Borehole Geophysical Research Laboratory at Karad, which was conceptualized as part of the Ministry's Scientific Deep Drilling Initiative in the Koyna Intraplate Seismic Zone dedicated to earthquake research. He is an expert in the field of heat flow and radiogenic heat production studies, geothermics of climate change, and scientific drilling investigations in active fault zones. Over to you, sir.
Thank you very much. First of all, warm greetings to all of you, to all colleagues from the different institutions of MOES and the Earth Science Fraternity on this occasion of the Ministry of Earth Science Foundation Day. And this comes from on behalf of all my colleagues at the Borehole Geophysics Research Laboratory in Karad. I've been asked to talk about the advancements in borehole geophysics research in India. And let me tell you at the outset that beyond the commercial domain, borehole geophysics has not permeated in a large way. But I'll show you, and I'll argue why this is so important for undertaking modern earth science research. And I'll take an example of how the ministry has taken a lead in this area and is trying to advance earthquake science at the Borehole Geophysics Research Laboratory, where we have taken up an experiment, a very ambitious experiment, to understand the causes of triggered earthquakes. As was very clear from the previous talks, a lot of earth processes, several earth processes that were discussed in the previous talks, and in solid earth, for example, the earthquakes and volcanoes, etc., owe their origin in the deep subsurface, that is below the surface, and the surface observations are not ideally positioned to capture all that is happening deep below. And therefore, you need boreholes to access the subsurface, to reach the subsurface at different depths, and then make measurements there in the near field of the processes that are happening. So that is in a sense, why borehole geophysics is important, and therefore scientific drilling is important, and therefore making deep borehole measurements and taking out samples of rocks from the deep underground and analyzing them in the laboratory, interpreting the data, etc., are important. Oh, I'm sorry. Okay, so I'll be very briefly touching upon the scientific drilling goals and the scope of scientific drilling investigations. And I'll focus a little bit on the understanding of the earthquake processes, particularly what is not known to us yet and how those processes can be addressed by borehole geophysics and scientific drilling and measurements. We'll touch upon a little bit on our Koyna experiment and the future directions. So as of today, how do we get insights into the Earth's deep interior? Broadly, there are three ways. Number one is using geophysical tools and methods. That is where we apply the indirect geophysical techniques like the seismic methods, the gravity, the magnetic method, etc., electrical resistivity, to understand the composition and structure of the subsurface. The other way is to study the xenoliths, which are really fragments of the mantle and the deep subsurface, deep crust that are brought to the surface when the magma comes up. And the third is by drilling into the earth, recover rock and sediment cores, and making downhole measurements to measure the in situ physical properties. But how deep have we gone so far? So if you look at this figure, this cartoon, for reference, this is the average thickness of the Earth's crust, continental crust, is about 35 kilometers. This is the average thickness of the oceanic crust, is about 7 kilometers. And these are the different boreholes that have been drilled. Some of the deep boreholes, like the Kola, has gone up to 12.2 kilometers. The KTB in Germany has gone up to 9.1 kilometers. And there are some other boreholes. And so, really speaking, all these boreholes have barely passed through, at most passed through a third of the continental crust. But still, those are important because they have provided information that have not been available before, and a lot of surprises, for example, fluids at depth, and so on and so forth. Now, if you look at the scope of scientific drilling, so globally, the scientific drilling has permeated into almost every aspect of Earth system science, as you can see in this figure, because scientific drilling provides exact, fundamental, and globally significant knowledge of the composition, structure, and processes of the Earth's crust, and helps us to confirm or reject the models that are based on the surface observations alone. And you can see that the different areas where significant advances have been made, for example, physical and chemical processes responsible for earthquake and volcanic eruptions. What happens under a volcano? Questions like that. Earth's changing climate and causes, some of that you saw in the previous presentations. The effects of major impacts, the meteorite impacts and climate change and mass extinctions, interactions of the deep biosphere with the geological processes, for example, the hydrocarbon generation, etc., the exploration of renewable energy resources, for example, geothermal energy, safe disposal of radioactive waste, which is a really important area that cannot do without studying the deep subsurface, because you need to, the geological sequestration of not only CO2 but also radioactive waste is one of the burning issues of the present generation, and so on and so forth. So, but basically, even if you want to know what is the structure and composition of the crust and the deep mantle, we need information constraints from the deep interior rather than from the surface methods alone. Now, why is scientific drilling an indispensable tool in modern earth science research? Because this is the only way we can get direct information on processes operating at depth. And the in situ properties of solid rocks and fluids can be obtained directly as they are below, not by taking them up and measuring in the laboratory. Then we can do direct sampling of fresh geological materials. So the geologists study outcrops, but if they get fresh materials from the boreholes, that gives them a much bigger leverage. Decision testing of geological hypotheses and models. And one very important aspect that has come up in the last few years is the use of boreholes as natural laboratories to carry out experiments of ongoing active processes, for example, earthquakes. And when you measure deep in the boreholes, you also cut off the surface noise, and you can record very pristine signals of the different processes that happen. And if you look at the scientific and social benefits of such drilling, so take the Earth system science has all these realms. For example, the georesources, the Earth's environmental change, the geohazards, earthquake, volcanoes, landslides, and knowledge of the Earth's interior. They are all dependent on scientific drilling because of society's increasing dependence on natural resources, to remediate the existing environmental damage, to sustain human progress without causing further environmental degradation, and to reduce our vulnerability to natural hazards. And that is why these tools can inform decision makers with key data on socioeconomic issues that are central to the human existence on Earth. What are the scales of observation? There are various scales. Now, if you look at the scales of observation, we can look at the scales from sub-millimeter levels up to tens of meters to hundreds of meters level scale. So if you look at thin sections and cuttings that you make from the rock cores that you get from depth, we can go to sub-millimeter levels as well. But if you look at the core samples, they can go up to 10 centimeters, and then in borehole measurements, they can give us information up to a meter to 10 meter scale. And then when you conduct different kinds of experiments in the boreholes, geophysical experiments, for example, seismic surveys, etc., you can go up to a kilometer scale. So these are all very important, and these are on the right-hand side, these are the photomicrographs of rock samples. What are the tools? What are the other tools of geophysics, of borehole geophysics? So you can make a number of downhole measurements. For example, electrical resistivity, natural gamma, sonic images. You can get very accurate, very high resolution images, both from acoustic as well as formation microresistivity data, the nuclear magnetic resonance data, density, neutron. You can do hydraulic fracturing, and you can fracture you can open the existing fractures, or you can create new fractures in a controlled manner by injecting boreholes in a controlled manner at a controlled rate from the surface down to subsurface, and you can measure the stress and other things. So these are some of the images, some of the tools that I just described. So this is logging inside a borehole. These are the kind of different physical and mechanical properties with depth that are measured in a borehole after drilling. These are the images which can tell us a lot about the fracture distribution, about different wellbore breakouts, stress, etc. And boreholes as observatories. These are really, really cool because you can actually lower different sensors like strain meters, seismometers, piezometers, thermometers, etc. Inside a borehole, and you can monitor the processes, the active processes, active earth processes in the near field over a period of time for several years. So I don't have to say this, but scientific drilling is really pushing the technology to the limit. Now people are trying to, we have already drilled into deep permafrost and lakes and active fault zones, continental crust, but the next frontier is drilling into the magma. And that's the real challenge, because if we are able to utilize at least a part of the heat that comes from the magma, that will solve a big chunk of the energy problem. Now, understanding earthquake processes, I'll limit my talk to this. So when an earthquake happens, there are a number of co-seismic processes. For example, the fractures, the faults, damage zones that are created. Now, only about 20% of the seismic waves they come up to the surface, and they are recorded in the seismic stations at various distances from the fault zone. But what about the other 80%, which actually go to overcome the frictional stresses in the subsurface and and creating fractures, creating the rupture, how the rupture is nucleated below the subsurface, how they propagate, and how they are arrested, how they are stopped. So these are really big questions, and these are not new questions, but very little has come out, we know very little even till date. And one of the reasons is that we have not really gone to the near field to understand what kind of changes, co-seismic, pre-seismic, co-seismic, and post-seismic changes that take place at such depths. In other words, to advance from the current empirical models to the full physics-based understanding of rupture processes requires to address several of these questions which which cannot be answered by surface geophysics alone. What are needed are a totally multidisciplinary approach. For example, geological structure and deformation, rock strength properties, fault friction, temperature stress, fluid pressure at depth, chemistry of the fault zone fluids, permeability of the fault zone, subsurface fracture patterns, and many of these need scientific drilling and measuring at depth under in situ conditions. But some of these also require, some of these cannot be done in situ, but they require very advanced laboratory experimentation. For example, how to measure the fault friction? You cannot do it in situ. How to measure the permeability? You cannot do it in situ very well. So there are certain things which need also, in addition to drilling, getting the samples up and measuring in the laboratory under simulated conditions, temperature and pressure and other conditions. Now, to answer these questions, how do we go about? So this is a very famous, very sage advice from one of the really great scientists who is no more. So he says, if you want to know the answers, ask the earth. So you have to question the earth. And how do we question the earth? So the earth is, you have to ask the right questions to the earth. So this is an example, this is a cartoon from the San Andreas Fault Zone drilling experiment in California, where they set up where the idea was to set up a deep borehole observatory and ask the earth several questions by placing different sensors at depth and monitoring over a long period of time. I'll quickly say a few words about our own scientific drilling experiment in the Koyna region in the western part of the Deccan Trap. So this is the geological map of India, and Koyna is here on the western part of the Deccan Traps near the west coast, about 60 to 70 kilometers east of the western coast, where in 1962, a large water reservoir, artificial water reservoir, the Shivaji Sagar Lake, was also known as the Koyna Dam, was impounded, was filled up. And the dam height is about 103 meters. The reservoir volume is about 2,800 million cubic meters. So it's a large dam. And soon after the impoundment of this dam, the seismic activity enhanced dramatically. And you can see here, this is the Koyna Dam. And there is another reservoir, the Warner Reservoir, about 20 kilometers, 30 kilometers south of Koyna. And there is the seismicity is plotted here. You can see these plots, the open circles of various dimensions. So these are the earthquakes of different magnitudes that have been recorded over the past 50, 60 years. And if you see there in the surrounding region, there are no earthquakes at all. So this is a very limited area where earthquakes are happening within a depth of maximum 8 to 10 kilometers. And the largest triggered earthquake of magnitude 6.2 has happened there in 1967. And the seismic activity is very clearly modulated by the annual loading and unloading cycles of these two reservoirs. So during the monsoon, there is loading. During the post-monsoon, there is unloading, things like that. Now, this area has been studied very well, and therefore this is a natural laboratory to take up further investigations through scientific drilling, and that is the goal of this program that the ministry has taken up. What we have done so far, we have drilled a number of boreholes up to 1.5 kilometer in the periphery of the seismogenic zone. This was done way back in 2012 to 2014. And later on, after BGRL came into being, we have drilled a 3 kilometer deep scientific borehole as a pilot phase to the main 5 to 7 kilometer borehole that we want to drill in the future. Now, this borehole has given us a lot of new information, new insights into what are the geological conditions that are responsible for the continued seismic activity over such a long time. So in 1962, the reservoir was impounded, and even today, almost 60 years down the line, we still have recurrent earthquake activity, continuously or persistent earthquake activity, and more than 20 magnitude 5 earthquakes have taken place so far. So why is this continuing? And so there must be underlying geological conditions that are responsible. And for the first time, we are able to get a control, to get a handle on those geological conditions by drilling this borehole. So this borehole went through 65 million year old Deccan basalt, 1.2 kilometers, and then 1.75 kilometers into the granite gneiss basement, which was not done before. And in the next phase, which we are planning now, we want to drill a deeper borehole up to the depth where the earthquakes are occurring and set up a deep borehole observatory there inside the borehole that displays sensors for long-term monitoring. So this is the Koena pilot borehole, a snapshot of our it was a privilege to be part of, to be associated with such a drilling program. It went up to almost 8 months. And this is the deepest borehole drilled in the crystalline basement in the country. And this was done in the seismogenic zone for the first time with indigenous expertise and resources. I don't know if this movie will play, but don't worry.
Which one, sir?
मूवी एक है ये. Yeah, so this just gives a quick glimpse, a minute's glimpse of how complicated and how involved such deep drilling operations can be in a place where basically no one lives, and this kind of a huge setup is necessary to carry out such deep drilling under controlled conditions to make the different kinds of downhole measurements in the borehole, and then to do the coring, to take out core samples from 3 kilometers depth, and so on and so forth. So, isko band kar dijiye. Yeah. So drilling of such a borehole was really a challenge because, the geology and the rock types were unknown, the depth was large, and then there are faults and fracture zones that you expect in such a zone where there is a lot of seismic activity. We had to maintain the verticality of the borehole to less than 3 degrees to do certain measurements, to coring and sampling of rocks from such depths, downhole measurements, etc., etc. So these are some pictures from the drilling. So you can see how the cores are retrieved from depth, and then they are subjected to different processes, and finally they are scanned and archived in the core repository that BGRL has now built. So there are different kinds of signatures, brittle deformation signatures that are possibly linked with earthquakes activities. For example, slicken lines, and these fault zones, small fault zones, and there are some displacements. You can see more slicken lines. You can see master faults with injection veins, with possibly chlorite or pseudotachylite material. If you get pseudotachylite, that's basically a melt that is generated during a seismic process, and so on and so forth. Now here at the bottom right, we have what is a very rare thing that we found is a shallow reactivated fault zone. And when we are doing a lot of microstructural work on such samples, in order to study the repeated fracturing, one set of fractures superposed on another set of fractures and things like that, and study the alterations, study the mineral inclusions in them, etc. So we have carried out geophysical well logs. So we have got a very good data of the physical and mechanical properties, variation with depth throughout the borehole, 3-kilometer borehole. We have very good, excellent images of the whole borehole. We have done the hydrofrac experiment at depth up to 2.4 kilometers in crystalline basement, which is only a very few of such measurements exist in the world. And we have finally interpreted this data, etc. We have done, when the drilling was going on, we have actually collected the gas samples, formation gas samples that come along with the drill cores, drill cuttings, and water, etc. And we have been able to see that there is a high abundance of helium-4 in the formation gases, much above the atmospheric abundance of 5.24, which again showed that there were a lot of fractures in the basement. So ultimately, we were able to identify a lot of fault damage zones in the basement that may be responsible for these repeated earthquake activity. We were able to analyze the image logs in more detail, and we could get the strike and dip of the different fractures, and then compare those fracture orientations with the stress orientations, and then ultimately come up with a hypothesis which shows that there are hydraulically conductive fractures, and if we consider hydrostatic pore pressure conditions, then they fall in the critical range of coefficient of friction 0.6 to 1, which means that if this is true, then the Koyna region is, we can say now that the Koyna region is critically stressed for hydraulically conductive fractures, and small perturbations to this subsurface stress regime, for example, which can be provided by the reservoir, can cause repeated failures, repeated earthquakes in the region. So this is one explanation that is coming from the subsurface. There are other constraints that are necessary from the laboratory, from the advanced laboratory experiments, which we are now planning to do. We are carrying out. Some of them are possible in the country, but many of them need a lot of more advanced laboratory facilities, which cannot be set up overnight. So we are establishing international collaborations and so on and so forth. But this is becoming a very interesting problem to pursue. And in the end, I mean, this is our final goal, to set up to drill down to 5 to 7 kilometers and set up a borehole observatory to monitor several physical and mechanical and chemical parameters that are associated with pre-seismic, seismic, and post-seismic changes that take place near the earthquake zone. So I'll not go into these. So these are different modeling studies that need to be done, combined with advanced rock mechanical experiments and in situ studies. So it's a fascinating area, a new area of research that has opened up, and we expect to understand the earthquake processes much better than we have been able to do so far using the surface geophysics alone. One last thing that came up out of this the experiment was the deep biosphere, and I'll show one slide here. So colleagues from the Indian Institute of Technology, Kharagpur, they collected different samples of these core samples at different depths, and they were able to find out, so they were able to extract the rock DNA from these rock samples and study the diversity and distribution of microbial life within the granitic crust at 3 kilometers, up to 3 kilometers depth, where the temperatures is of the order of 80 degrees Celsius and pressures of 3 kilometers. So to understand the significance of the deep life in the biogeochemical cycle. So these kind of studies have brought out very new and better understanding on the organization and functioning of microbial life under such energy-starved deep biosphere conditions. And these highlight the species interaction and the biogeoscience, biogeochemical aspects as well, roles. So these new findings hold promise for the future microbiological exploration of deep habitats and getting leads from these extremotrophic microorganisms for various biotechnological processes, for example, carbon capture and sequestration, waste repository and remediation, biodiscovery and novel molecule discoveries for industrial use, etc. So this is, I've borrowed this slide from the International Continental Scientific Drilling Program, of which India is a member through the Ministry of Earth Sciences. And they have a very clear goal of geohazards. They have a clear geohazards program where I think the people all around the world are trying to understand and address such questions, such broad questions, such as what are the drivers initiating and controlling earthquakes, volcanic eruptions, and mass movements such as landslides. And these are global problems. They are relevant to India. How do we distinguish faults, volcanoes, and potential landslides that present an immediate threat from those with low hazards? how do we build a better quantitative understanding of physical processes, allowing us to provide advanced warning time to mitigate such risks and geohazards. And we have a number of interesting problems in India that can be taken up. For example, we have the interplate earthquakes near the plate boundary, but we also have very damaging and devastating intraplate earthquakes within the plate interior. And one of the things that we do not understand yet is how much the plate boundary forces actually impact or influence these plate interior tectonic processes. So there are many things that we can do in India as well on this. And these are the geohazards, interesting geohazards drilling projects that are going on all over the world on both earthquakes and seismicity, impact craters and volcanoes. Now, as the last slide, how do we use our current understanding acquired through these kind of researches in objective hazard assessment? And this is an important thing which also has been addressed in a very limited way so far. So because our understanding of these processes are still incomplete, and the site-specific conditions that matter, for example, the location of the faults and the stressing state, we have very little information so far on such issues. But a comprehensive risk management governance strategy must include a suitable monitoring infrastructure, sophisticated data analysis techniques for real-time seismicity characterization, quantitative risk analysis, and the transparent decision protocols. Many of such issues are being addressed by the National Center for Seismology at the ministry, and I think some more advances need to be done combined with the borehole geophysics information, and finally we should be able to evaluate the system response before the occurrence of critical events. Things like Secretary Dr. Ravichandran mentioned in his opening remarks. So we need additional data, modeling, and research efforts. I think that's the bottom line. We need additional data, modeling, and other research efforts in order to address such issues. So in conclusion, I'd like to just summarize that the scope of scientific drilling and applications of borehole geophysics are immense, and they are poised to grow rapidly as both industry and the academia realize its potential to provide cost-effective and direct information on the processes occurring at depth. This is inherently a multidisciplinary area, and that is why the borehole geophysics research laboratory at Karad that has been is under development and is trying to include a multidisciplinary expertise there, multidisciplinary capabilities, geology, geochemistry, seismology, hydrology, geophysics, and of course complex system modeling, etc. And we are looking forward to scientifically exciting and new research opportunities that have now opened up in frontier areas that can be addressed through the borehole geophysics. Thank you very much.
Thank you, sir. We thank all the experts for sharing their insights with us. With that, we come to the end of the morning session of the program. Namaskar. Good afternoon. I once again welcome the entire MOES fraternity to the 17th Foundation Day celebrations of the Ministry of Earth Sciences. Ladies and gentlemen, please welcome on stage our chief guest, Honorable Union Cabinet Minister for Earth Sciences, Shri Kiran Rijiju, who has graced us with his presence today despite his busy schedule. I also request Secretary, Ministry of Earth Sciences, Dr. M. Ravichandran, ASNFA, Shri Vishwajit Sahayji, Joint Secretary, Shri Senthil Pandyanji, to join the Honorable Minister on the stage. I also request the dignitaries on the dais to kindly light the lamp. I request Sri Senthil Pandyanji, Joint Secretary, Ministry of Earth Sciences, to deliver the welcome address.
Good afternoon to you all. Chief guest of 17th Foundation Day celebration, Honorable Minister of Earth Sciences, Shri Kiran Rijiju, Secretary MOES, Dr. Ravichandran ji, Additional Secretary and Financial Advisor, Shri Biswajit Sahai ji, Head of the institutions, distinguished scientists, dedicated staffs associated with this ministry, participants attending online, ladies and gentlemen, on behalf of the Ministry of Earth Sciences, I extend a warm welcome to all of you on this occasion of the Foundation Day of the Ministry of Earth Sciences. Today we gather here to celebrate the milestones achieved by this esteemed ministry over the years and to look forward to a future filled with innovation and sustainable development. The Ministry of Earth Sciences, through its various institutions, research centers and programs, had significantly contributed to the scientific understanding of our environment, thereby enabling evidence-based policies and decision-making processes. Its efforts in meteorology, oceanography, seismology, and polar sciences have not only enhanced our ability to predict and mitigate natural disasters, but also have contributed to safeguarding lives and properties. Moreover, the ministry's contributions extend beyond the boundaries of India. In collaboration with the global scientific community, it has actively participated in numerous international projects and initiatives, reinforcing India's position as a formidable player in the field of earth sciences. As we stand here today, it is important to recognize the challenges ahead. Our planet is facing unprecedented environmental changes, with climate change being a pressing concern. It is the duty of the Ministry of Earth Sciences to lead the way in finding sustainable solutions, promoting alternative energy sources, and raising awareness about the need to protect and preserve our natural resources. I would like to take this opportunity to commend the scientists, researchers, and dedicated staffs associated with the ministry for their unwavering commitment and contributions to the field of earth sciences. In alignment with the Honorable Prime Minister's announcement, under the direction of Honorable Minister of Earth Sciences, we are celebrating Azadi Ka Amrit Mahotsav activities focusing on public outreach for farmers, fishermen, and students through the whole of government approach. I would also like to express gratitude to the Honorable Minister for the continued support and encouragement in fostering scientific advancements. Once again, I would like to welcome you all. Thank you all for being here today to celebrate this significant milestone. I wish you a fruitful and inspiring Foundation Day celebration. Jai Hind.
Thank you, sir. I now invite Secretary Sir to address the August gathering.
Honorable Union Minister, Minister of Earth Sciences, Sri Kiran Rijiju ji, former Secretary, Dr. Sailesh Naik, directors of our esteemed institutions, Director General of Meteorology, ASFA, Sri Viswajit Sahai, JS Sri Sendil Pandian, distinguished scientists, researchers, colleagues, staffs, and all our guests. Very good afternoon to all of you. I am pleased to mark this occasion of the 17th Foundation Day of the Ministry of Earth Sciences with all of you today. My wishes also extends to our colleagues working from the Indian Research Station in the Antarctica, the Arctic, and the Himalayas, and our centers, onboard ships, observatories, and labs spread across the country, including those in the remote, unique locations and difficult terrain. I am humbled and honored to address this gathering, celebrating yet another year of citizen-centric scientific accomplishment and milestones of the Ministry of Earth Sciences. Over the years, we have achieved several milestones, adding new feathers to our crown of glory. The responsibilities that we have been entrusted with align with our Honorable Prime Minister Sri Narendra Modi ji's vision of powerful, prosperous, and emerging new India, capable of making its presence felt at the world fora. Towards this aim, and with the support of our Honorable Union Minister, Ministry of Earth Sciences, Sri Kiran Rijiju ji, we strive to continue to work towards better, more efficient, faster, and more valuable services to our nation and our people. The Ministry of Earth Sciences is a unique ministry which, based on its scientific and technological expertise, has the mandate providing the expanding services and knowledge about our planet and the complexities that make it extremely special, ranging from providing accurate and timely weather and climate-related information, including forecasts, nowcasts, to monitoring phenomena such as earthquake, fog, and pollution, etc., helping address environmental issues, giving data-based, science-based advisories such as potential fishing zone advisories, ocean-related services and risks, to exploring and harnessing deep-sea resources, undertaking research in Earth's pole, the Arctic, Antarctic, and the Himalayas, to issuing some timely warnings such as tsunami, cyclone-related alerts. The Ministry of Earth Sciences has been at the forefront of contributing to saving lives and livelihoods and contributing to the growing economy of our country. I take this opportunity to thank our visionary predecessors, scientists, researchers, scholars, staff, stakeholders, and collaborators for their unwavering support in all that the Ministry of Earth Sciences has achieved and for the progress that it has been making. Particularly in the past 9 years of the visionary leadership of our Prime Minister, we have accomplished progress that has been crucial to our rapid growth and work that has been aimed to make our nation self-reliant or Atmanirbhar, aligned promoting startup and Make in India in our endeavors. One of the flagship scheme of Ministry of Earth Sciences, which has been conceived to implement in the recent past, is the Deep Ocean Mission. Launched in collaboration with the various stakeholders, this ambitious project aims to explore and harness the various resources of our ocean sustainably. We have launched the Samudrayan mission, India's first manned deep sea mission. We have successfully conducted the locomotion trials of the deep sea mining system in the Central Indian Ocean at a depth of about 5270 meters. We have explored marine biodiversity and shall develop the infrastructure and technologies for deep sea mining of valuable resources. As part of Deep Ocean Mission, we shall also witness the significant improvement in our weather and climate and ocean-related services. Setting up a dedicated center for advanced ocean biology research, development of cutting-edge submersibles, deep-sea equipment, and specialized ocean energy-powered plants that will help improve the lives of our citizens. The Deep Ocean Mission, in addition to opening new avenues of blue economy, will enhance our understanding of the enigmatic realm of the oceans. I would also draw your attention to the recent cyclone, Biborjoy, predicted very timely, including its track and intensity. Because of the significant lead time, disaster management authorities could align well, which helped save precious lives. It also demonstrated our country's pursuit, will, and action to collaborate with the neighboring nations for the common good. We have released timely information on potential tsunami related events, earthquake related observations, heavy rainfall alerts, weather, fishing zones, and ocean forecasts through website, apps, and social media. Several training and workshops of our last mile users have been conducted. With immense pride, I say that we have continued to touch everyday lives of our citizens. For all our services, we have successfully deployed the latest digital modes of the communication for dissemination information to our people and stakeholders. These includes our institute's active social media handles, website, and mobile apps of many of the things. We have launched 6 new Doppler radar in the last 2 years, and it has been helped many of the places now cost, apart from installing 200 automatic weather stations, especially in agro automatic weather stations. The aim is to cover entire country with a radar network of Doppler radars and 660 agro automated weather station by 2025 for more accurate forecast, especially related to extreme weather events. We have helped expand the South Asia flash flood guidance system to provide flash flood guidance to our neighbor Bangladesh, Bhutan, India, Nepal, and Sri Lanka together. This year, some of our colleagues from MOES were elected to eminent positions at the international scientific fora, such as Vice President of the World Meteorological Organization, Intergovernmental Oceanographic Commission, and also the Project Management Committee leader, chair of that Global Flash Flood Guidance System of World Meteorological Organization. MOES has set up coastal observatories along the coast in the last 2 years, including Kochi and Visakhapatnam for real-time monitoring of the coastal waters, apart from water quality monitoring from the ships. 6 new thermal desalination plants were established with a capacity of 1.5 lakhs per day are being set up at Lakshadweep in the last 2 years. Such initiatives reaffirm our commitment to supporting environment-related work and services to our people. When discussing citizen-centric initiatives and connectivity, we must discuss the Swachh Sagar, Surachit Sagar campaign, conceptualized and initiated by the Ministry of Earth Sciences, which became a massive citizen movement to combat marine litter pollution. It brought together the young and concerned people to do their bit for the environment. And the trend has continued, and there have been successful beach cleanup initiatives by the ministry and its collaborators, where we have witnessed enthusiastic citizen participation and partnership. We have launched many of the new research vessels in the last 2 years, especially the coastal research vessels, Sagar Anvishika. It is in operation, and there are many other research vessels also in operation in various oceans. When discussing our endeavors, we must discuss our polar endeavors, which are unique to this ministry. We have successfully concluded 42 expeditions to the Antarctic and more than 12 expeditions to Arctic. We have released our country's first ever Arctic policy and enacted the Antarctic Act. Our Honorable Union Minister has announced that the Indian research base in the Arctic, Himadri, shall be manned around the year in the coming years, which opens up far more opportunities for scientific research and collaborations. We have been working towards strengthening our international ties, especially in the areas of scientific and technological merits. These initiatives set our commitment towards international peace, harmony, science, cooperation, and sustainability. We have supported, in principle, and executed in action the free sharing of the data and information we generate from all these peers. We have launched the Earth System Science Data Portal in the year 2021, and this portal hosts more than 1,050 metadata records of data collected, maintained under different programs implemented by Ministry of Earth Sciences. This time, India has hosted G20 meetings. As part of the G20 meets, our ministry has basically spearheaded the Blue Economy component of the Research and Innovation Initiative gathering of G20. Apart from participating in the Environment and Climate Change working group meeting along with the Ministry of Environment and Forest. Of course, the Ministry of Earth Sciences has been making significant progress in seismological sciences. Another unique center of the MOES, the Borehole Geophysical Research Laboratory, which is entrusted with the objective of studying scientific reasons for a reservoir-triggered earthquake in the Koyna region in Maharashtra, is steadily expanding its necessary infrastructure and would set up the state-of-the-art digital library of the earth crust specimens in the future. The seismic microzonation studies that help our authorities better adapt to earthquake-related challenges are all in full swing for 4 cities and progressing well for 8 more cities in the coming months. All earthquake-related information is round-the-clock monitored and disseminated very promptly through website and various social medias. These achievements represent just a fraction of the remarkable work done by Ministry of Earth Sciences and its team. We have done a lot, but there is more that we must do. We must remain steadfast in our pursuit of knowledge, innovation, and sustainability. The challenge ahead for us are powerful and immense. Climate change, natural disasters, marine pollution, and depleting resources, to name a few, are threatening us. However, I am confident that with our strong foundation, energetic youth, dedicated research, and spirit of collaboration and cooperation, we will continue to make significant strides in addressing these challenges and securing better future for our planet. The last month was phenomenal because of Ministry of Earth Sciences has finalized the procurement of an upgraded high-performance computing system from 6.8 petaflops to 18 petaflops, 3 times faster. We are very proud to have the most powerful supercomputing facility in the country dedicated to serve our nation. The upgraded supercomputing facility will help improve our weather and climate modeling accuracy and resolution tremendously. The latest procured computing facility is set to be operational by this year end. Under the guidance of our Honorable Union Minister, we are set to launch a slow, remarkable, and valuable service-oriented initiative for the public on our 17th Foundation Day today, such as new med centers, website, web portal for block-level weather forecast, Indobis and deep water crabs collected, library, mobile app for ocean-related services at one place, a video on MOES and its activities, a documentary on cyclone warning and management in India, and also 330-meter resolution of Delhi fog model by NCMRWF, and also the final report of KIPEX project, what we have done by IITM. I once again call upon all my colleagues to celebrate our achievements and acknowledge the hard work of our institute and our team players. I thank and extend my warm wishes to everyone associated with the Ministry of Earth Sciences. In the coming years, I am sure with all your support and contributions, MOES will grow much more heights and our contribution will be significant for the growth journey of India. May we remain dedicated to our service to our nation, our people, and the champions of progress. Thank you one and all. Jai Hind.
Thank you, sir. To mark the 17th Foundation Day celebrations today, we have a short video that showcases the scientific endeavors of the ministry that are primarily service-oriented to bring about positive impact in the everyday life of the citizens of the country.
In July 2006, the Government of India upgraded the Department of Ocean Development to the Ministry of Earth Sciences, or MOES. It also approved setting up a body called the Earth Commission under the ministry. Soon the MOES administration brought several leading institutes, laboratories, and other prime organizations under its purview. Today, the ministry is providing valued services through its various institutions.
हमारे पूर्वज समंदर पर अपना वर्चस्व इसलिए कायम कर पाए क्योंकि उन्हें हवा की दिशा के बारे में अंतरिक्ष विज्ञान के बारे में बहुत अच्छी जानकारी है। किस ऋतु में हवा की दिशा क्या होगी, कैसे हवा की दिशा के साथ आगे बढ़कर हम पड़ाव पर पहुंच सकते हैं, इसका ज्ञान हमारे पूर्वजों की बहुत बड़ी ताकत है।
Namaskar. Embracing the vision of Honorable Prime Minister Sri Narendra Modi ji for a new India, we at the Ministry of Earth Sciences are committed to the idea of one Earth, one family, one future. Our work in unraveling Earth's complex system not only aids in protecting our people's lives and livelihoods, but also epitomizes Seva, our service to the nation. Our determined scientists and collaborators across domains such as meteorology, climate research, geosciences, and oceanography are vital in pushing the frontiers of science and technology. Together, we aim to achieve the PM's vision of a successful blue economy. We remain committed to fostering a sustainable planet and making our services more accessible and beneficial for our citizens. Together, we are building a future that is green, healthy, and sustainable. Thank you. Jai Hind.
The Department of Ocean Development has started in the year 1980s, in the early 80s. Mainly look at it, the ocean resources and its associated services. I think over the period it has come a long way. Then it has started with the oceanographic observation as well as services. And also India has launched Antarctic expedition in 1983. And later on, whereas the atmospheric component like weather and climate and seismology, earthquake related, all these things is done by the Department of Science and Technology. But later on in the early 2000, the government decided, I think this is a working ocean and atmosphere. They are both are symbiotic relation. So the government thought that it has to be merged together, and they formed the Ministry of Earth Sciences around in 2006.
India is preparing not just to become a self-reliant nation in science and technology, but to rise once again as the Vishwa Guru, the epitome of knowledge.
Next week. Infographics. Oh, sorry. The infographics of MOES will now be released by the minister. Please, sir. Thank you, sirs. Next, we have a video on cyclone warning and management in India, which is an end-to-end system that showcases the role of early warning system and multi-institutional mechanisms in effective mitigation of disasters associated with tropical cyclones.
Hindi presents a film on cyclone warning and management in India, an end-to-end system. The film emphasizes role of SOP and the coordination among National Crisis Management Committee, 3-tier disaster management authorities, and emergency operation centers for cyclone disaster management.
इस साइक्लोन में मौसम विभाग ने टेक्नोलॉजी का बखूबी उपयोग किया।
मेट्रोलॉजिकल डिपार्टमेंट ने बहुत accurate information दिया है.
The warning system has improved accuracy. They have brought in the forecasting processes. Equipment of India Meteorological Department has improved.
We are able to work together.
Sufficient time was provided to all along the west coast, to all the states and all the stakeholders.
The film showcases improvements in early warning services through impact-based forecasting, risk-based warnings, and the use of common alerting protocol and social media for effective disaster mitigation. These advancements have significantly reduced cyclone-related death to less than 100 in recent decade over the region and has ensured security to life and livelihood at sea and over land, including farmers and fishermen.
It is a constant endeavor of the Ministry of Earth Sciences and the India Meteorological Department to increase the operational reach of forecasts so as to reach maximum people in the country. In line with this mission, IMD has set up 4 new meteorological centers at Imphal in the state of Manipur, Kohima in Nagaland, Airswall in Mizoram, and Port Blair in the Union Territory of Andaman and Nicobar Islands. I request the Director General, India Meteorological Department, Dr. M. Mahapatra, to kindly come up on the stage. And I request the Honorable Union Minister to inaugurate the new meteorological centers of IMD. Thank you, Sir. The Indian Ocean Biodiversity Information System, INDOBIS, is an open access data portal on marine biodiversity of the Northern Indian Ocean. I now request the Director, Center for Marine Living Resources and Ecology, Dr. GVM Gupta, to come up on the stage. And we take this opportunity to request Honorable Minister to launch and release the INDOBIS portal.
Ocean Biodiversity Information System, INDOBIS, is the regional OBIS node for the Indian Ocean, hosted by the Center for Marine Living Resources and Ecology, Kochi. It emanates from the Ocean Biodiversity Information System born out of the international project, Census of Marine Life. The INDOBIS web portal hosts digitized information on voucher specimens of biological samples and fish otoliths preserved at the CMLRE Referral Center. It also provides access to the checklist of marine species of Indian waters, taxonomic catalogs, information on new species, and new geographical records published by CMLRE. Under INDOBIS, a comprehensive dataset containing 110,000 occurrence records of marine species from the Indian Ocean has been generated from primary and secondary data. The statistical information derived from this data, along with spatial maps, is made accessible to users through the Web GIS component of the INDOBIS portal. The web portal facilitates the publication and sharing of biodiversity data to the global database, OBIS, providing researchers an opportunity to publish the data against their own credentials. Additionally, it provides information and guidance on the use of biodiversity data for education and research. The INDOBIS web portal delivers state-of-the-art services to society, including decision-makers, enabling them to assess biodiversity changes from various perspectives. As part of INDOBIS, CMLRE is working on developing a user-friendly mobile app to engage citizens in collecting real-time information on marine species from the field.
As part of the seamless modeling activities, the National Center for Medium Range Weather Forecasting proudly presents the DM-CHEM, which is a 330-meter high-resolution city-scale model for predicting fog in terms of visibility and PM 2.5 over Delhi and the NCR region. DM-CHEM incorporates detailed urban features such as building height, aerosol chemistry, and cloud microphysics, and impact of irrigation for accurate simulation of winter weather characteristics over Delhi and the surrounding regions, which is of immense societal value. We will now play the video.
Delhi, the capital of India, stands in a triangle formed by the river Yamuna in the east and spurs from the Aravalli Range in the west and south. While holding its traditional values, the city on the other side is getting flourished, with modernization resulting in rapid urbanization, pollution from traffic, industries, and construction activities. In particular, every winter, this region faces the recurring problem of fog, impacting air, rail, and road travel, while exacerbating the air pollution. To address this, the National Center for Medium Range Weather Forecasting under the Ministry of Earth Sciences presents DM-CHEM is a state-of-art fog, visibility and air quality forecasting system which is still under constant evolution and progress. WCSSP India provides a platform to share, discuss and evaluate the advancement happening in weather forecasting system, especially for high-impact weather. DM-CHEM is an upcoming and very promising numerical weather prediction model for the bright future of multiple cities in India for the betterment of the life quality of our citizens. Thus, it is an ongoing research activity which can transform our lives and livelihood.
I now request the Director, National Center for Medium Range Weather Forecasting, Dr. V.S. Pradas, to come up on the stage. We are delighted to have the new website of NCMR-WF to be inaugurated by the Honorable Union Minister. Search on the tape. The Indian Institute of Tropical Meteorology, Pune, has conducted in-depth investigations to test the feasibility and effectiveness of cloud seeding as part of the cloud aerosol interaction and precipitation enhancement experiment, the KIPEX Phase 4 at Solapur, Maharashtra. The outcome from this experiment shows that cloud seeding is an effective strategy for enhancing rainfall in a region under suitable conditions. Over a period of 2 years, scientists at IITM evaluated 276 clouds to test the effectiveness of cloud seeding. We will now play a video on KIPEX.
Cloud Aerosol Interaction and Precipitation Enhancement Experiment, KPEX, is a program of the Ministry of Earth Sciences, Government of India, conducted by the Indian Institute of Tropical Meteorology, IITM Pune, to understand the impact of aerosols on clouds and precipitation processes. More importantly, KPEX provided a scientific basis for estimating the feasibility of cloud seeding for precipitation enhancement, which is required for formulating guidelines and protocols for cloud seeding operations. KPEX was conducted in 4 phases. In the last phase, KPEX focused on randomized cloud seeding.
KIPIX experiment was conducted in Sholapur on the basis of recommendations by the WMO. The randomized experiment indeed resulted in 267 samples of convective clouds, which is first time ever in the world, these many samples, and we have indeed evaluated those samples to make recommendations for the cloud seeding. There are nearly 5,000 cloud penetrations we have done, which is also unique, and this have indeed been very useful in studying the cloud microphysics and precipitation of the region, and it will be used by many researchers in the field to make further more findings.
I now request Dr. R. Krishnan, Director, Indian Institute of Tropical Meteorology, and Dr. Thara Prabhakaran, who steered the program, to kindly come up on the stage. We request the Honorable Union Minister to kindly release the KIPIX report to the scientific community. Thank you, madam. Thank you, sirs. To enhance the dissemination and utilization of ocean advisory services, Indian National Center for Ocean Information Services has developed a mobile app known as Samudra that empowers users with real-time updates and alerts on ocean disasters such as tsunami, storm surges, high waves, enabling individuals and communities to stay informed to protect life and property. The app also offers valuable potential fishing zone advisory services that guide fishermen to the most probable fish aggregation locations, thereby maximizing catch rates. The app provides a 5-day advanced ocean state forecast, enabling coastal communities for mitigating risks and optimizing operations based on the predicted ocean conditions. We now play a video on the Samudra app. Humbly request our Honorable Minister, Shri Kiran Rijiju ji, to kindly release the compendium of monthly seismological bulletins for the year 21-22, which contains a voluminous phase arrival data from a total of 3,500 well-located and recorded local and regional earthquakes by the National Seismological Network. We also request Dr. O.P. Mishra ji to please come up on the stage. Thank you, sirs. Momento. Thank you, sirs. I now request the Honorable Union Cabinet Minister, Sri Kiran Rijiju ji, for Earth Sciences to really please address.
Learned Secretary, Ministry of Earth Sciences, Dr. M. Ravichandran ji. We have former Secretary of the Ministry, Dr. Sailesh Naik ji, present with us. Additional Secretary and Financial Advisor, Sri Vishwajit Sahay ji. Joint Secretary, Sri Senthil Pandian ji. All the directors of the institutes under the ministry, all the distinguished senior scientists, officials, all our stakeholders, our collaborators, our invited guests, and those who are linked to this program through online video conferencing, media friends. Let me congratulate the entire fraternity of our ministry on the auspicious occasion of the 17th Foundation Day. In fact, I was also a bit surprised that so many launching of programs, inaugurations, release of books were kept for this day. And that also shows, in a way, how much works are being done on the ground. I had many occasions to attend many functions, especially on the occasion of the Foundation Day, but it is never like this. So many programs in a day. That shows how much our highly talented, skilled scientists, researchers, scholars, and the officials are engaged with various works in respective fields on the ground. And rightfully, on the occasion of the 75th year of India's independence, we are celebrating Azadi Ka Amrit Mahotsav. So this period of Amrit Kal is very important for us, and it is quite heartening to see that our ministry is also progressing very fast. I had mentioned in some of the interactive session in the past that Prime Minister has given a very clarion call to the nation with a vision to make India a fully developed country by 2047. And to fulfill that vision, every member in our country, every citizen will have to make substantial contributions. So our ministry must also ensure a target which we will have to set by ourselves and achieve through our endeavors. The contribution of this ministry through various scientific aspects and the contribution from the ocean in India's economy is indeed unlimited. We still cannot calculate what and how much the ocean can contribute to India's economy. Comparatively, some of the countries which have lesser coastal lines have ensured larger contribution of the ocean in their economy. And we will have to assess it. And rightfully, the blue economy has been launched, and the policy and all the ideas about the blue economy is pointing towards that India has a great future when it looks towards ocean. And the progresses made are tremendous. The advancement in different sectors whether it's in the field of atmospheric science, climate, weather, or in ocean, or in the seismologic things. I think I do not need to elaborate. Each institute has made substantial progress, and rightfully we have already launched so many booklets and other journals and many programs. So, following the vision of the Honorable Prime Minister, I'm proud to say that our ministry is moving in right direction with proper support from the government, from the policy level. I'm sure we will move much more faster in the days to come. There are some areas we need to really go much deeper, whether in the space or ocean or inside our earth crust. The more we learn, we find the more is to be learned. It's unlimited, unconquered. The horizon is so huge, so large, that there is unlimited possibilities lying ahead of us. Today, most of our senior officers are here, and you have seen in past few months, I had visited some of our prestigious institutions, and I'm very impressed with them. And some of our directors are here. There are a few more centers which I have to visit. But those centers where I have been to, I am extremely impressed with not only the administrative management, but the scientific advancement and the success achieved so far. I had also had the opportunity of interaction with our scientists who are there in the Arctic Circle and in the Antarctic. The expedition team in Antarctic were larger in numbers. I had the opportunity to interact with them, and I had the opportunity to visit the Arctic Circle, where we have our research station, Himadri, in Svalbard Island. And I was there, and I had a very good experience, first-hand experience, which were being assisted by the government of Norway. The Norwegian authority were very helpful. In fact, the Norway's proposed ambassador to India and our ambassador to Norway both accompanied me, and I could really understand on the ground that we have been there, but we will enhance our capacity. As Secretary had mentioned, we have already checked out our programs and policies. The journey ahead will be interesting but not easy. The Deep Ocean Mission, which we had launched 2 years back, I think it has one of the largest scope, and we have full confidence that we will successfully accomplish the Deep Ocean Mission. And the other missions are there, the Monsoon Mission, in the Arctic Mission, in every sphere. We have to work in the missionary zeal. And some of the achievement we have gathered so far, it's very encouraging. I'm not going to go into details because the Secretary has already explained it nicely. He is in a way gone through the entire journey in a nutshell, and very encouraging to see. Only on the occasion of 17th Foundation Day, we have achieved so much. But although the existence of ministry may be 17th year, but the working of the sector is old. For example, the IMD, the most, I think one of the larger share of our ministry's manpower is there, because IMD is present in every district, in every airport, and every important center. And it's established in 1875. So one of the oldest institutions in our country. So Foundation Day may be not old, but the existence of our field activities are very old. And when we got a new ministry, we have to make it more visible. So I had mentioned in the beginning also when I took over this ministry that the visibility is extremely important because the common people must feel connected with the works which our scientists have achieved. All the works done by the scientists are for the common man, to make India great actually. And as long as we can disseminate all the information which is for the common people as easily as possible through various apps or other information mechanism which we can develop, it is better. For any ministry or center, the connection with the common people in a much more easier fashion will be the success story. So that is how I feel that our scientists are working quietly. I had the occasion of interaction with so many people of different sectors. I had the opportunity to serve in various ministry. Prime Minister has been kind enough to give me the opportunity to serve in so many ministries. I had experience to deal with the youth, the sports persons of the country. I had the experience to deal with the doctors when I was holding the Ayush ministry. And I was in the Home Ministry, so I dealt with all the security people. And I dealt with the Ministry of Law and Justice, so I dealt with the lawyers and judges. So sometimes in a lighter vein, I say that dealing with judges and lawyers and other people may be a little difficult, but dealing with scientists is the easiest. The scientists are focused in their own field. They are so focused that they don't really bother about other things. So I find very interesting to work with the team which we have in this ministry. There are so many things to share about, but I feel it may not be necessary because it will be a bit repetitive of what Secretary had mentioned and what our Joint Secretary had mentioned in his welcome address. But sometimes I feel that teamwork is the secret of the success. The more collaborative efforts we can put in, the more rate of success we will achieve. So collaboration with different centers, with the foreign institutions, and the collaboration within the colleagues is extremely important. And all our centers are sharing informations and other things. The inquiries have a direct link with so many things with our IMD. In a similar way, all the centers will have something good to share and supplement with each other, which are very important. And with the kind of support which we are getting from the leadership, from the Honorable Prime Minister, in the days to come, the role of our ministry is going to be much more than what we have and what we are doing right now. Because the way the weather, the climatic change which we are witnessing, whether it's in the ocean or in the inland, onshore, offshore, inside the earth, it's all changing so fast. We are observing it with our own naked eyes. Within our own lifetime, we have seen so many changes. So the role of the scientific community will play a critical role. And when we talk about the climate change, it is so fast that sometimes we are puzzled. We even don't know how to behave because the larger pattern is neutralized by some localized phenomenon. And some activities which occur locally can, do away or can turn around the larger picture which we provide. So when I was in the Home Ministry, I used to ask Dr. Mahapatra, can you predict the cloudburst? So that was around, I think, 8-9 years back when I was in the Home Ministry. He said, sir, it is difficult to predict cloudburst. But carefully, if we see, we can, but it is not easy. But for that, we have to take certain extensive and intensive steps to see that the requirement is met by that kind of support system. In a similar way, if somebody says, can you predict earthquake? Of course, right now we cannot predict earthquake. But some Jyotishi somewhere will say that earthquake is happening on that particular day. And it creates, tizzy amongst the scientific community. Many a time, some Panditji or somebody will say that earthquake is going to happen on that particular day. So, ultimately, everything will fall on the scientist. So, but I am very sure that in the days to come, all our seismologic research which is going on will definitely give some clue. We know what is happening, but we can't predict. But prediction is the real success story. Today we are talking about the success of the IMD. It's all because of the predictions. If we are correctly predicting the tropical cyclone, all the heat waves, rainfall, everything, it is directly visible and benefiting the people. So the success rate is considered very high. In a similar fashion, the fishermen are very excited, which we launched the app today. Now the fishermen will be precisely aware of when to venture out into the sea and how much fish they are likely to catch. So these are the scientific inputs which we are providing, and it is going to have a huge benefits to our economy, and that will lead to the prosperity for our fisher works. So all the sectors which we are working as a vast canvas. That is why I said in the beginning, I was also not very much aware of the details about activities in this ministry. But there are tremendous success rate if we see each sector-wise. So every center I visit, I feel so proud that so much achievements have been made so far, but we are going to achieve much more. So on the occasion of the Foundation Day, I feel it is moment to reflect on our journey, how much and how far we have traveled, and also to assess and also to visualize how far we will have to travel. It's a very critical ministry. I realized when I visited Norway last month, the whole their government have put so much of emphasis on the climate, on the blue economy, the deep ocean activities, all the activities in the polar region. So definitely now the common man of India are also talking about climate change, which was not even a topic of discussion some decades back, but now it is a priority for every nation. Today, we should remember some of those who have been pioneering in this respective field. Some of the scientists, some of our senior officers may not be with us today, but they have led from the front. Yesterday in the IMD Center, I saw some of the former Director General's photographs. I feel nice because they serve these institutions. Similarly, there are always pioneers who had started the mission, and we are following them. In a similar way, the upcoming younger generation will follow the present team. So we have to set a mark which our next coming generations will feel proud of us. Wherever we are, in whatever position we hold, we will have to make and leave behind some indelible mark to show that we have really devoted our time, energy, resources for the nation. So on the occasion of this Foundation Day And on the occasion of 75th year of India's independence, we all have to set our target for next 25 years as a one medium-term goal. And beyond that also, we will have the long journey. But in 2047, where will our ministry be? Each center must set some agenda. So I would like to request all the head of the institutions, our directors and senior officers to make a visionary document or visionary some kind of target for each center to be achieved in next 25 years, so that when India becomes a fully developed country, which Prime Minister has already committed, in 2047, where will we be? Our ministry as a whole will have a vision, but each center must set a target. And that will be a good benchmark for all of us to follow. So with that few words, I am grateful that I am being made to release so many important books and journals and inaugurations and launching of many things which are critical for our nation. Since we have launched so many programs and books, it will not be easy to put forward in social media and all in one day. So from tomorrow, maybe each day, we will focus one subject, one center each day, so that for next 1 week or 10 days, we can keep on celebrating our extended Foundation Day. So thank you very much. My best wishes to all the members, and thank you for organizing this wonderful Foundation Day. Thank you very much.
Thank you so much, sir, for your kind words of encouragement. I now request Secretary Sir to kindly present a memento to the Honorable Union Minister on this occasion of our 17th Foundation Day. I now request Shri Vishwajit Sahai-ji, Additional Secretary and Financial Advisor to the Ministry of Earth Sciences, to propose the vote of thanks.
Shri Kiren Rijiju, Honorable Union Minister for Earth Sciences, Dr. Ravi Chandran, Secretary Ministry of Earth Sciences, Dr. Shailesh Nayak, former Secretary Ministry of Earth Sciences, who's being kind enough to grace this occasion, directors of all our institutions, DG Met, colleagues from the ministry, ladies and gentlemen, it gives me immense pleasure to propose a vote of thanks at the end of this MOES Foundation Day function. You just heard our Honorable Minister giving a rousing speech in which he has, appraised and assessed and praised the performance of our institution. That gives us great heart and encouragement that the Honorable Minister has taken note of the good work being done by the institutions. I'd like to thank him and thank all the directors for the excellent work that is being done. I would like to express my sincere gratitude to Honorable Minister, Shri Kiren Rijiju ji, for sparing his valuable time to be with us on this occasion. So we made note of some of the points that you mentioned, especially about having a vision document 2047 for fulfilling the commitment of the Honorable Prime Minister to making India a developed economy by 2047. We have also noted the point regarding enhancement of visibility, a point that you made very often with all of us. And I'm sure we'll all, as a team, strive to fulfill the mission that you've set for us. I would like to assure the Honorable Minister that the MOES family of professionals will always be in pursuit of acquiring advanced knowledge and dedicate themselves towards making the ministry as one of the best in the world in providing services on weather, climate, ocean and seismology, and the exploration of the deep oceans and polar regions. We would like to thank all our former secretaries, former colleagues, people who are senior officers who are online, colleagues from MOES institutions, friends from the media who have watched this function live through webcasting. Last but not the least, I thank all my colleagues from MOES who have helped in organizing this Foundation Day function. Thank you. Jai Hind.
Thank you, sir. Let us all stand up for the national anthem, please.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उज्जल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you, everyone. Kindly join us for tea arranged in the dining area of the Arnav Hall in the third